That's it. Good morning, sir.
Uh,
Rashid, sir, good morning.
Good morning, ma'am. Good morning.
Okay, sir, would you like to share your screen
Yeah,
and
yes.
check it?
Okay, ma'am. I have sent the request.
Yes, sir. You can share now.
Okay, just yeah.
Yes, sir, it's visible.
Is it okay now?
Yes, visible, sir. It's visible.
And what about the hours?
Yes, sir, it's visible too.
Okay, thank you.
Thank you, sir. Okay, good morning, dear participants. We are good to start. So we have with us the resource person for our day 5, and our resource person is Dr. Rashid PP, and Sir is an doctorate in finance from the School of Business Studies, University of Calicut. Currently, Sir is working as a faculty member in Institute of Analytics, International Skills Development Corporation. His research focuses on hedging, derivatives, and currency markets. He has published papers in journals of repute and has presented papers in multiple national and international conferences. Sir is a sought after resource person for workshops in business analytics, econometrics, and research methodology. So, we are very happy to have you here with us. And Sir will deliver a session on hierarchical linear modeling in the first session of our day 5. So I request the participants to take the maximum advantage of our experienced intellectual resource person and make the session interactive. In case of any doubts and queries, you can use the chat box, or if the case is such, then you can also unmute yourself and interact. So thank you, sir, for being here with us. I hand over the session to you.
Okay, thank you, ma'am, and all other participants. Most respected faculty members from various universities, research scholars, and all others, those who are participating in this workshop. Initially, I thank the university for giving me an opportunity to deliver a session on hierarchical linear modeling. And today we will discuss something about the HLM model, where we'll give I thought we can have a time for giving an introduction about this hierarchical linear modeling and how to do this with the R. Later we can develop initially if you get some idea with the help of other tools and all. We could develop these things in our research. So I welcome again all to this session. I'm just starting. If you have any queries, you can unmute and ask. If it is known to me, surely I will reply to this, or otherwise later I will revert to you. Okay. And our session objective is there are 4 objectives I have thought to complete by this time. We know it is only a limited time is available, just 2 hours. Within that, initially, I will try to understand, I will give you the concept, what it really mean by hierarchical linear modeling and what is the need for this hierarchical linear modeling. From the econometrics, in earlier sessions, you have find or identified the different econometric tools, OLS regression and all. From these tools, how it is differentiated and what is the linear modeling and what are the theoretical basis that we should know while doing this model. And with these basis, we'll move on to the R for the practical session, and finally how to interpret the result. Okay, these are the session's objectives. Initially, I will start with a small meaning or definition of hierarchical linear modeling. This hierarchical linear modeling, it is also known to be multi-level modeling. In another name, it is called as multi-level modeling, or mixed effect modeling also it is called mixed effect model, where we are using fixed and random effects. So it is known to be mixed effect model. And where it is using, that is the most important thing we need to know. If the data is nested or in hierarchical structure, in such a condition, we will use the hierarchical linear modeling. So we may have a doubt what is really mean by nested data, or what is real meaning of hierarchical structure. So we will start with an example of these things. Just as an example from an organizational hierarchy. if you are studying about the employees itself, they could be considered as the level one, the employees. And the second one is they are nested in the department, which means that each employee is part of one department. Some of them may come coming from IT department, from finance department, HR department, marketing department, and all. So these employees are nested in the department that is known in, you could consider it as a level two. So in each department, they may have some specific features, peculiarities, and further we can nested into the firms. Firm A may have a different culture from firm B. Those employees are coming from firm A may entirely different from firm B. So they nested again in firms. So if an organizational structure, we are studying about the employees' performance and all, we could not say that these employees have different opinion or perception and all without considering these things. That is, their department have an influence on their work culture, their firm have a influence on their work culture, satisfaction level and all. So we could say hierarchy. Level 1, just employees, and level 2, they are grouped in the department, and level 3, they are in same firm. Or some of them are from one firm and others are from another firm and all. So in such a structure, that is known to be nested or hierarchical structure. This is one example. And if you are considering the marketing studies, customers, simply we are considering customers. Okay, level 1, we could classify them into 500 customers. But each region, they have some peculiarities. Northern customers will be entirely different from the south, from the east, west, or the central part of India, or even if we are considering the state itself, they may have different cultures and all. So they are nested in the region or okay, and macro level context, if you are considering uh, the total firms, they are nested with the industries, uh, manufacturing industry, firms in the manufacturing industry, or steel industry. From there may be entirely different culture or different situations from car industry and all. So they are nested in the industry itself. In such a cases, this type of data is known to be nested or hierarchical structure. Okay. Then normally we will have some doubt. There are different types of econometric models are available. OLS model, simple regression, or if we have more than one independent variables, we could have multiple regression and all. Why we go for the hierarchical linear modeling? Here I am giving one example that is related to the case which you are already discussed in the first case. That is impact of training hours on employees' performance. We are going to study if you are giving more hours for training, whether this training have any influence impact on the performance. So for that purpose, we have take data taken from 200 employees, those who are working in 20 different departments. Okay. And if just we are analyzing the OLS regression, what will be happened? Each employee is considered to be independent. That is, Mr. X is entirely different from Mr. Y. Y is entirely different from Z. Z is entirely different from A. Likewise, we will consider 200 employees are independent. But if you are thinking a practical case, uh, if the if these 200 employees, among these 200, 50 employees are from the marketing department, may have a same type of culture, or their managers training have an influence on all these employees that may be entirely different from the IT department. Or if you're considering the finance department, their work culture, their environment is entirely different from the marketing department. So we could not say that if 20 employees are from the marketing, may have something peculiar features they are holding. It is entirely different from the culture which is held by the finance department. So we could not say all the employees are different. These 20 employees from marketing department have some differences, but they may hold some common features. They share some common ideologies, some common work culture and all. So we could not consider, we could not do a simple OLS regression and just saying that these 200 employees are different. So we are checking whether this training have any influence on their performance, and out of this 200, how much of them were getting increased, or on an average, what is the effect and all. So without simply taking these cases, we could not say that these 200 employees are different and they have a different culture or different effect on employees' performance. So each department have some influences. In such a case, we requested to go with the hierarchical linear modeling. Okay. And if you're considering the OLS regression, we have a assumption that independent observations that we are already said. That means error term for any given observation is uncorrelated with the error term of any other observation in the data set. That I thought you already heard these things in earlier sessions. That is related to the correlation while they are considered while they are speaking. This base is already been discussed, and this is the one of the basic assumption of OLS regression. That is, error term is uncorrelated with the error term of other observations, but it is not the exact in case there is a grouping. And this is the real condition what is happening. Non-independence occurs. That means the group have some common or similar features. So we could not simply say that each one is different. Each error term is different. That is not the exactly what is happening in the market or what is happening in the real condition. Where if you are ignoring this clustering, what will be happening? That is given here. As already been discussed that in OLS regression, the error term are uncorrelated with the error term of other observation, and that is not the real condition if there is a group. And if you are ignoring this clustering, it may leads to these situations. First one is the standard error of regression coefficient are underestimated. We could not say the exact standard error. We could not find or take the exact standard error if you are considering each individual as separate. If the standard error are underestimated, automatically it will lead to a reduces the p-value. If the p-value is reducing, that may leads to the type 1 error. That means we are rejecting a true null hypothesis. Something may be there, but we are rejecting that. That may happens. So if the clustering is ignored and we are going simply with the OLS regression, these things may happen. First one is the standard error of coefficient is underestimated. Automatically that will leads to the reduces the p-value. If the p-value is reducing, that have a chance of inflated probability of type 1 error, that is the true null hypothesis will be getting rejected. So these are the issues what is really happening when we are going with the OLS regression. So in order to overcome these issues without hierarchical linear modeling, we may do some other methods. That is inadequate. Why it is inadequate? There are two methods we are using: disaggregation and aggregation. Disaggregation means that we are already discussed. Each individual is or each respondent is considered to be different. They are not same. If you are considering like that, standard error will be getting biased and it will leads to reduces the p-value and automatically the inflated risk of type 1 error will be happened. So this is the first thing happen that, or we could say this is the aggregate method if you are going with the disaggregation that we are already discussed in before. And if you are trying to aggregate all these things, that means instead of going with individual level, we are grouping everyone or taking the average of each group and doing the research with this average. What will happen next? That is, we are losing the statistical power and information. That is, for example, in earlier cases, uh, 20 employees from IT department. Among these 20, Mr. A get 20 hours of training and he has a high uh, growth rate. And Mr. B also received 20 hours, but his growth rate is very low. Likewise, differences will be there. But if you are considering just an average, which means total of these 20 employees, what their performance and taking the average and how much hours they are received the training, taking the average. If doing likewise, that is aggregation method is doing, we are losing the statistical power, which means individually there will be some differences which is not to be considered. So it will leads to risk of ecological fallacy. It is not to be risk of ecological fallacy. We are concluding individual relationship are incorrectly drawn from group level analysis. That means if you are taking a simple example, uh, just take our students case. We are just analyzing if the students are reading more, whether they will get higher mark or not. On an average, only if you're taking on an average, we are saying that, okay, if they're reading more hours and they're getting more mark. But if taking individually, Mr. A, the student A, he read only 1 hour per day, but he is getting highest mark. Mr. B or student B is reading 6 hours per day, but is getting least mark. So there will be differences from individual to individual. That is not considering if you are taking the aggregation. Just an average, that is a real issue with the aggregation method. That is known to be a risk of ecological fallacy. So, if there is a cluster, if you are doing disaggregation, entirely ignoring all the uh, group and different, then there may be type 1 error, chance of type 1 error will be getting higher. And if you are only considering the averages, then the risk of ecological fallacy will be getting higher. That means we are losing the differences from individual levels, individual relationships are losing. So these, from the discussion, we could conclude that disaggregation is inadequate. On the other hand, aggregation is also inadequate. So in order to overcome these issues, aggregation and disaggregation, we have developed the method hierarchical linear modeling. Okay. I hope you could get a understanding on why this hierarchical linear modeling is used and what it is important. So, and another uh, two terms, we should have know what is the differences between these. Otherwise, there is a chance for we are moving without the exact way. So that is hierarchical linear modeling that we have just discussed, and hierarchical regression also there. It is entirely different. Hierarchical regression is entirely different from hierarchical linear modeling. Both are not same. So we will just making differences. What is hierarchical linear modeling and hierarchical regression? Hierarchical linear modeling HLM, that we have already said that if the statistical analysis is used on nested structures or grouping data, that is known to be hierarchical linear modeling in order to identify the group differences as well as the individual differences. But hierarchical regression means uh, we, simply we can say this is a model comparison. This is a framework for model comparison normally used in the OLS regression. This hierarchical regression means if you have a 8 independent variables, initially we are adding 3 independent variables and we are checking how these independent variables have an influence on the dependent variable. Later we are adding one more. Initially 3, then 4, then 5, then 6, like that. We are adding one by one extra one independent variable in order to identify what change is happening in the dependent variable, or is there any improvement in the R square. In order to identify these differences, we are using hierarchical regression. Okay, this is the model which is used in the OLS regression. The same method is used in OLS. There is no differences, but in order to identify what is the changes happening in the R square, if you are adding one or more independent variables, we are using hierarchical regression. The base of this hierarchical regression is that if we have different independent variables, so we cannot apply all or include all the independent variables for the research study. For that purpose, initially we are checking most important 3, then we are adding one more, then we are adding one more. Which model is getting highest R square, that model we will consider for the study. In such a case, we are using the hierarchical regression. So it is same as the multi regression, okay, hierarchical linear modeling, and so we could conclude that hierarchical linear modeling is entirely different from hierarchical regression. Hierarchical regression is a method of OLS in order to reach the best R square. Okay, and this is the table which is given the differences between OLS regression and hierarchical linear modeling. The normal regression, how it is differentiated from the hierarchical linear model. If you are studying these things, we'll get a clear idea on where it is differentiated and in what condition we can use OLS, in what condition we can use HLM. Okay, in the data structure, we are assuming in OLS, we are assuming every individual is independent. But in the HLM model, we are nesting the data or grouping the data, and in that way only we are going for the analysis. Then group effect, group membership is ignored in the OLS, or all the categorical predictors are fixed. That means in group 1, group 2, or in different departments or different region, all those regions baseline is considered to be fixed. There is no distinction is considering in the OLS, but in the case of hierarchical linear modeling, random variable is using. That means group 1 may have differences from the group 2. Likewise, we are going for the analysis. And the standard error, we have already said that there may be a bias while doing the analysis, and it may lead to type 1 error. But in case of HLM model, it is an unbiased and accurate model because each data group to be differentiated, and we are considering only a single variances. But in case of HLM, the group variance is also considered. That means between the groups and within group variance is considering. that is fixed effect model and random effect model is combined in the HLM model. But how different individuals in a group, for example, in IT department, 15 employees are there. How these 15 employees are differentiated? That is considering in HLM, and also how this IT department is differentiated from finance department. That is between group variance also considered in HLM. And we are going with the research questions. In OLS, it is the research question. What is the average relationship between X and Y? For example, here, what is the average relationship between the training hours and the performance? But in HLM, we are trying how this relationship is vary across groups or different departments. How much it is effective in IT department, what is the difference in marketing department, how it is differentiated from the finance department. Likewise, we are checking. That is hierarchical. These are the basic research questions which is used in the hierarchical linear modeling. Okay. So I hope you get some basic idea on how this OLS is differentiated from hierarchical linear modeling. Okay, then we are moving on to the concept of multi-level model. We have already said that this hierarchical linear modeling is also known as multi-level models. Why it is multi-level models? When we are doing the hierarchical linear modeling, we are starting with the null model or unconditional mean model. In unconditional mean model, just I'm giving a theoretical base for this. You will get a clear idea while we are doing in practical cases using the R Studio. We are saying that there is no independent variables. We are just checking if there is nothing as independent variable, what will be the differences between different groups. Or is there is any variance exists between group 1 and group 2. That is unconditional mean modeling or null model. Okay. Then we are considering in level 1. Here already said that the variance exists within group 1 and variance exists between groups. These two things we are considering in the null model. So within group model, this will be the equation Yij is equal to beta O plus R. That means outcome of a group individual is a function of mean outcome of the group, and there are some individual error terms. That means some individual differences will be there. So within group, we are considering what will the mean of group on an average, how this group is performing. And also we are considering the individual differences. Okay, that is within the group model. And between group means we are considering it is as a function of overall grand mean across all group. If there is 5 groups are there or 5 departments are there, what is the average mean of all these 5 departments, and how what one group is deviated from another group, or how the first department is deviated from the second department. Likewise, we are considering between group variance. So here in null model, initially we are checking individually how they are differentiated and what is the average of the group and how they are differentiated from this group average. In the between group, we are checking all groups average and each group, how each group is differentiated from this average. And in the combined model, we are integrating between group differences and within group differences or variances. And with using these two models or two levels, we are checking what is the average score of individuals. Okay, I hope you could get the idea. In combined model, that is in the null model, we are combining what is the differences individually from group, that is within the group, and how this group are differentiated from another group between groups. These two things were combined in combined model. Okay, so by considering the individual differences within group and the groups different grand mean, these two things were combined and we are checking what will be the individual's score or what will be the individual's performance, whatever we are studying. Okay, this is the combined model. And if there is, if the null model is found that there is a deviation, then we'll check the ICC, that is interclass correlation coefficient, that is denoted by rho. This ICC quantifies the proportion of total variance from between group and within group. Okay, while we are checking the equation, you will get more idea. This is the equation for ICC, interclass correlation coefficient, proportion of total variance explained by group membership. That is between group variance divided by between group variance plus within group variance or total variance. That is interclass correlation coefficient. Between group variance divided by total variance. That is between group and between group and within group variances. That is ICC. Okay, this is the another term we are checking in hierarchical linear modeling. That is, if we could find there is a significant variance in ICC, then only we move for the hierarchical linear modeling. And this is the base what we are checking. If the ICC value is greater than 0.05 or at least 0.1, then only it is justifiable that why we should go for the hierarchical linear modeling. Or simple term, we are saying, or with an example, I could say, if you are checking uh, 200 employees that we are already discussed, 200 employees we are taken from different departments, and whether we are checking, is there any significant differences, variance from different groups to groups among total variance. And we find that 0.15. That means IT department, HR department, finance department, all these departments are variated about 15 percentage. Their performance are variated about 15 percentage. So if you could find at least 0.5 or 0.1, then we can move with the hierarchical linear modeling. Or otherwise, if you could not the variance, then it is not required to go for hierarchical linear modeling. Simply, we can check with the OLS. That is, we need only to check or we are considering all these individuals are different and we are checking how the performance is affected by the training. There is no such a distinction. There is no need for the distinction from different departments. Okay, I hope you could get a basic idea about ICC. Here, this is very important in hierarchical linear modeling, or we could say it is the entry form to the hierarchical linear modeling. Once we are passed in the ICC, then only we can go for the hierarchical linear modeling. Otherwise, there is no need for go with the hierarchical linear modeling. Instead, we can do with simply with the OLS regression. Okay, here we are checking between group variance divided by total variance. Okay. And another term we have to find is fixed effect and random effect. Because initially we said that in the hierarchical linear modeling, it is also known as mixed effect model, or we are considering both fixed effect and random effect. Uh, while we are checking with the panel data analysis, hope you have heard the fixed effect model and the random effect model. Which should we go for? Whether to go for with a high fixed effect or with a random effect. Likewise, when making the decision. So, in this hierarchical linear modeling, both fixed effect and random effect are considering. Okay, fixed effect means average effect, or it is better to understand with this example. Years of experience on performance that we are checking. The average increase in the performance for each extra year of experience for all employees. That means we are considering if the year of experience is increasing, whether the performance is increasing or not. That is for all employees that are same. That is fixed effect. We are only checking or considering every department is same, and from where we are starting. That is fixed effect model. And in the random effect model, the fixed effect might vary between different groups. That is, in a real condition, every single group may have different variance. So, in order to check the overall variability, we are using random effect. Okay, in the fixed effect, just I'm giving very brief things. In the fixed effect, years of experience and performance we are considering, and we are checking what will be the change if experience is increasing and how this experience is influencing on the performance. We are not considering the differences from one department to another. Okay. And random effect, we are considering these things also. Overall variability, we are checking. That is random effect. So, in the hierarchical linear modeling, we are using both these models for regression analysis. And another one is random intercept and random slope. Random intercept and random slope. A random intercept means we are considering different department have different baseline. That is, intercept may be different. Intercept, hope you could know that if you are making a regression line, if the independent variable is 0, what will be the dependent variable? Likewise, we are checking, that is the intercept. In random intercept model, we are considering each department may have a different baseline, but the slope is always same. Okay, that is, for example, the performance and this years of experience we are considering. Then years of experience may be difference from one department another and all, but their slope, if years of experience are increasing, the proportion of change will be same for all the department. That is considered in the random intercept. That is, the base will be different, but the slope will be same. Random slope model means both these things also change. That is, the baseline may change and also the slope may also change or variate. It is the real condition what is happening. Okay, then we are moving different approaches to model building. This is directly related to the practical cases. Okay, Initially, we will start with the null model, or we could say unconditional mean model. And uh, here we are checking. Here I am not given the direct meaning. Instead, the real conditions or the practical cases I am given as an example because it is for better for to understanding. Okay, in unconditional mean model or null model, starting with calculating average job performance across all employees and all department. So we are checking if there is any differences in job performance from departments to department. Okay. In unconditional mean model, we are only checking the job performance has any significant differences from department to department. That is only thing we are checking in the unconditional mean model or null model. We are already said that there will be no independent variable. Then random intercept model with level 1 predictor. Level 1 predictor means initially we said that the employees are in the level 1, department in the level 2, and the firm in the level 3. So in the random intercept model, we will add one predictor. Here we are adding years of experience. That is, if there is different experience for different employees and how this difference is have an influence on the employees performance. So in the random intercept model, we are adding one predictor, level 1 predictor. It is years of experience. I hope you could getting some idea. If you have any doubt, please ask. After clarifying only, we'll move on to the next. Then mean as outcome model. In the model 3, here we are adding a departmental variable, level 2 variable. For example, managers experience. Managers experience. How this managers experience making differences in the employees performance. In level, just in, I'm starting with again starting with the model 1. Null model, only we are checking this employee's performance is differentiated from one department to another. There is no other independent variables. In model 2, we are add a level 1 predictor that is related to employees to experience or years of experience. And mean as outcome model, in the model 3, we are adding a variable that is related to the group, that is managers experience we are adding. Okay. And in the fourth model, random coefficient model, we are checking employee level factors like experience actually same in every department. Okay. In the model 2, we are added or checked whether employees experience has any differences. But in the model 4, we are checking if different employees have different experiences, whether these experiences make the performance same in every department. If there is any changes. Okay. What it's asked. If you're checking this, you will get more idea. Does an extra year of experience provide the same performance boost in sales department as it does in the marketing department? That is, employee is appointed with a 5-year experience. He may, same way, another employee is appointed in the marketing department with a 5-year experience. And if their experience is getting higher, hyped, is this experiences make the same level of performance in sales department as and the marketing department? Is there any differences that we are checking in the model 4? And Model 5, intercept and slope as outcome model. Intercept and slope as outcome model. Okay, we are checking with this thing. Why the effect of experience varies across department? We need to know experience, how this experiences is varying. And in order to check, is it is related to department factor, that is level 2 factor, we are adding one more variable, that is annual training budget. Okay. And if you are checking the what it is asked, then you will get more idea. Does having larger training budget, okay, does having a larger training budget, that is department level factor, is this explain why experience has an impact on performance in some departments. So we are checking, or we are said that if more experienced employees have more performance in sales department but not in finance department, and we are finding whether it is related to training budget is given more in sales department, not in finance department. This is the factor that we are checking in the model 5. Okay. I hope you will get some idea on these things. In unconditional model, there is no, we are only checking is there any differences. In model 2, we are added one predictor, and here we are added one more predictor which is related to the level 2 factors, that is in department factors, and random coefficient. We are checking all the department is same, or is there any differences. And in level 5 or model 5, we are using, if there is any differences, is this differences is related to or with the use of group factor. That is we are checking in the model 5. And these different models will be using. How to choose the best model? For that purpose, initially we'll check the likelihood ratio test. And if you are adding more complexities, that is from null, we are adding one level 1 factor. Then we are checking whether these differences. We are adding one level 2 factor, and we are checking this level 1 differences is related to level 2 factor and all. If you are making the complex, the likelihood ratio said that which word is the best model. And also we are used AIC and BIC score. AIC means information criterion, and Bayesian information criterion. If the AIC and BIC score is getting lower, then that model is considered to be best model. In the first, for example, AIC we are getting 8,000. In the second model, AIC we are getting 7,000 or 7,500. So we can say that the second model is better than first model. And moving on to the third model, then we get a 8,500 AIC value. Then that is not better. So we will stop with the second model itself. That is the base for AIC and BIC. Then another one is centering level 1 predictors. That is, if you are using level 1 some predictors, we have to average the value. For that purpose, we'll use two methods, grand mean centering and group mean centering. In grand mean centering, each individual score on predictor is deviated from overall sample mean. And group mean, or it is also known to be centering within the context. Each individual score is deviated from group's mean. Grand mean, how it is deviated from overall mean, and group mean, we are checking how this average is deviated from group mean on that predictor. Okay. This is all about the very brief on the theoretical aspects, and we'll move on to the practical. Now you can open the R Studio, and I hope we're already given the uh, one data set. You can open that data set, and we will do all these things what we are discussed here one by one, and trying to find where we have to stop and how to make the hypothesis, and how to uh, whether to accept this hypothesis or not, or where to stop the uh, model and all. Okay. I hope everyone is uh, open the R Studio. Please open R Studio. Then I have shared one CSV file that you can open. For that purpose, import dataset. I hope it is visible. R Studio. It is visible, I think. If it is not, please let me know that. Okay. And from reader, text reader, click on that and browse where is your data is given. Then just select the data, open. When you're opening the data set, I hope everyone is doing with me. Uh, Employee ID will be there. Then organization, what is the age of every employees, then years of experience, and what is their education qualification, whether they are bachelor degree, master's degree, or whether they are holding PhD and all, that is given in education. Then next one is what is their current salary. Then another one is job satisfaction. This job satisfaction, work-life balance, job autonomy, then superior support, all these are in the 7 scale. Okay. We are used 7 scale for Likert 7-point Likert scale for this data set. So that is in the 7-point scale, and next we are moving. Another categorical variables are there. That is gender is given, whether they are male or female or not, and from which department they are belonging to, and what is their organizational size. Different organizations are also there. That is level 3 organizations also there, whether it is medium scale, large scale, or small scale and all. Then type of industry, which type of industry, manufacturing industry or any other industry is this, and which type of leadership style is they are following, transactional, transitional, or laissez-faire leadership style is following by the group leader, and how much is the training budget allocated for each department. Okay. And finally, the average salary of the organization. Total organization's average salary. How much is the average salary for total organization? Okay. These are the things were given in the data set. I hope everyone is taken this data set. And please import the data. Once we are imported, we can give a name that is data for this data set. For later purpose, it is better to give the name like data employee satisfaction HML model have changed the name into data. Okay. Then for getting a basic information about the data set, we'll use str. Str, like it. Data. This is showing what type of data is included in each columns. Employee ID, it is double, that is character data, or mm, whether it is numerical data and all. And the summary will give you a summary of all the variables. These are the basic things. I hope everyone know well all these things. Summary. If you're checking the summary, you will get what is the minimum value of that one, and what is the maximum value. For example, years of experience, minimum 0. Just freshers also there. Then maximum 24 years, sorry, 24 years experienced employees also there. And on an average, mean is 10 years, the average value like that. We'll get a summary about the data. Okay. Then checking the hierarchical structure. Checking the hierarchical structure. Okay, sorry for the delay. I thought someone is asking some question. Okay. Uh, we are using this equation, that is number of organizations, length, unique data from the organization ID. Okay. Cat is using to get the a heading for the one while we are doing the things, or it is not necessary to get. Okay. And while we are checking how many organizations are there in our data set. So the length, unique data, dollar organization ID, and we need to get in the numbers. So 15 organizations are there. Okay. Another one we are checking average employees per organization. Average employees per organization. If it's not clear, visible. Okay. Average employees per organization is around 54. I hope it is not need to be done now, because these are not the base for hierarchical linear modeling. We are just checking the summary about the data. And next one is table. Sorry, table, not tablet. Table, data, dollar, organization ID. So we will get this information in the first organization, how many employees are there. In the second organization, how many employees are there. Likewise, we'll get this information. Okay, well, checking this in the 12th organization, 53 employees are there, like that. Okay, so from this, you will get a summary about the data. Then before moving on to the hierarchical linear modeling, uh, we are making some basics about the data sets. Okay, for that purpose, this exploratory data analysis is using EDA. And for doing this one, percentage, greater than percentage, likewise, we need the deployer. So if it is not installed in your system, you can do install.packages in double in colon dplyr deployer. Okay, dplyr. Once you are installed, we can recall this library. Okay, I'm just checking the organization status. What is the mean of satisfaction? What is the mean standard deviation of satisfaction, minimum value of satisfaction and all. For that purpose only this is using, and I am not recommending to do it now because it is not the base for or not required for doing the HLM. But before moving on to HLM or any other analysis, we need to get some basic idea about all these things. That is why we are using this EDA and view the organization stat. Okay. From the earlier code, we will get that organization ID. What type of organization is this? For example, first one is a medium type level organization, size organization, and it is belongs to manufacturing industry, and transactional leadership style is following there. Total 68 employees are there. Their average satisfaction is 5.64 out of 7, and their standard deviation is 1.39. I'm not uh, detailing about the what is mean by standard deviation and all. I hope you have the all the idea on those things, and what is the minimum value and maximum value of the satisfaction. Okay. Likewise, all the 15 departments, organizations, what type of the organization is this and which industry it is belonging, and what type of leadership style they are following and all, we can identify it from this EDA code. Okay. And next one, we are checking variances at different levels. Okay, like deployer we are already taken. Within group variance, total variance. In ICC, we are already discussed that between group variance divided by total variance is using. Then for that purpose, initially manually we are checking what is the variance. Total variance is equal to variance, then data. Among the data, we need to check the variances of job satisfaction. Okay. So initially we are created a specific value total variance. And how much is the variance across the departments or inside the organization, how much is the variance within the organization. Okay, within organization variance, for that purpose we are using this code. And between organizations, what will be the variance, organization variance. And with these things, we can check the ICC. Okay, just moving on to the we are already said what is ICC means. Okay, this is the code for finding ICC, between group variance divided by between group variance divided by within group, between group divided by total variance. That is ICC we are checking. It is proportion of total variance explained by group organizations or group memberships. So ICC we are doing with that. We need to make it round into 3 digits. So we are using round. Between organization variance divided by between organization variance plus within organization variance. While we are checking this ICC, we could find that 0.189. 0.189. What it really mean by 0.189? That we are already said in the theoretical session. If the organization variance or the ICC is more than 0.5 or at least 0.1, that is there should be minimum 5% variance or a 10% variance, then only we can go with the hierarchical linear modeling. Here in this case 18%, we are converting into percentage, it will be 18%. So from these analysis we could conclude that, or we could say that, uh, I hope it is clear for this. You can view between organization variance is 0.33 and within organization 1.4. Oh, sorry, this is the final result. Okay, this is 0.8 189. So 19, around 19% total variance in job satisfaction is explained by organizational differences. That means if there is a change or differences in the job satisfaction, that is among these differences, 18 or around 19% is related to the organizational factors, and 81% is uh, within the organization or individual factor. But uh, organizational factors has minimum 19%. 80% variance is related to the individual, sorry, group factors or organizational factors. So there is a chance for moving with the hierarchical linear modeling. I hope it is clear for you. From this analysis, we are finding at least or around 19% variance is within between group variances. Okay. Among total variance, 19% is between group variances. HR department or department 1 is different from department 2 in the organizational performance, and this performance difference is not only because of the employees but due to the departmental changes, and 19% are related to that only. For that purpose we are using ICC. It is the basic checking. I hope it is clear. Then next one is if the ICC, initially we will check the ICC and we are fine it is more than 10%. Now we can move on to the null model. I think one message came. Okay. Then we can move on to the hierarchical linear model. Initially, we will use the null model. I hope it is clear for you. Null model is the first model. There is no independent variables will be there. Okay, for that purpose, we need a LMER package. If you are not installed, please install that install.package. In W comma, you can use LMER. Okay, I have already installed this, so I am not doing it again. And just loading library LME4. That is will be the code for loading the LMER package library LME4. Okay. Once we are loaded, we can go with the null model calculation. Okay. Before moving on to the null model calculation, I will just tell you what will be the null hypothesis we are using in the null model. Okay, here we are checking the null hypothesis will be there is no significant variance in job satisfaction between organizations. That is organization 1 and 2 or 3 all are same. There is no significant variances. And we should keep in mind that the null model, any other model, if you are going this model, initially we have to check the ICC and make sure that there is some considerable variance. Okay. In the null model, this is the hypothesis, null hypothesis. There is no significant variance in job satisfaction between organizations. Then this is the code for null model. That is model null. We are just giving the name model null is equal to LMER package. We are using LMER. Then we are checking the differences in job satisfaction tilde 1 because we are not using any independent variables plus 1, sorry, in bracket 1 organization ID comma. We are giving the comma because no independent variables are there. Data is equal to data itself. We are given the name data. Then REML is saying it is false. We are not considering this. Okay. So it is created a null model. We'll check the summary of this null model. Initially, we'll check the minimum random, okay, residual value is given here, variance and residual. With this, we can find the ICC and what will be the fixed effective estimator, and t value is more than more than 2. It is significant. Okay. This is a brief about the null model. We are using with the maximum likelihood. That is for that we are given this, and from the null model we are identified that there is a significant variance between and within group. Okay, this is the variance. I hope you could find. Organization intercept is this one, and residual 1.49. That much differences will be there, or a variance will be there in within group and between group variances. Once we are checked with these things, then we'll calculate the ICC from this null model. Okay, we are already checked one ICC, that is we are taken manually, and here with the help of RMLE or LM model, maximum likely with the help of maximum likelihood model, we are checking the ICC once again in order to ensure that the ICC we are already find is accurate. And variance component, initially we are checking. Then we know that we want to check between group variance and within group variance, between variance, organizational variance, then within variance, and ICC is equal to between variance divided by total variance, and between variance and within group variances. and print ICC will show that this is the exact ICC value, that is 0.6 also 0.167. Initially, while we are done manually, we find that around 18 percentage or 19 percentage. Here also, this comes to be around 16 to 17 percentage variance is due to the group variance or within variance. Sorry, between variances are there. Okay, I hope it is clear for you. That is uh, with the help of maximum likelihood model. Initially, we check the null model, that is without any independent variable, whether we are checking is there is any significant changes between different departments or groups, and we are found that significant change. And once we are sure that there is a significant change, then we will checking how much is the change. For that purpose, we are using the ICC. Okay. Once we are check the ICC, the value it is getting is 0.673. That is around 16 percentage of the variance are there related to group variance. While checking the null model summary, organization level variance is 0.2832. That we are already checked here. Okay, I will maximize this thing. Okay, this is the variance, group level variance. Then residual within organization variance is 1.4. That is individually there will be some changes and its value is come to be 1.4. And where this 1.4 is coming, this value is taken out of 7 because their satisfaction level we are taken in the 7-point scale. Where this much differences will be there in the individuals to individual within the organization. Okay. And we are also find that job grand mean job satisfaction is high. 6.11 is there. 6.1, sorry, 6.11. This is the estimate of intercept. That is, there is no other variables or independent variables is not considering. While we are taking the grand mean of average performance, that is comes to be 6.11. That is out of 7, on an average, the total employees having a higher level of satisfaction, 6.11. That is the major identifications from the null model. Okay, and then we are moving on to the ICC. ICC, we are already said that with the help of maximum likelihood model, we again checked because we are only find in the null model, that is there is a significant organizational level variance and within variance also there. So we are checking whether is there any significant variance between the groups, and for that purpose we checked the ICC and found that around 16 percentage of the variance, more than 16 percentage of the variance related to group level factors. So we get a license. Okay, I already earlier I told it is the entry form to the hierarchical linear modeling. Okay, next one is random intercept model with level 1 predictor. Okay, for that purpose, level 1 predictor means the predictors or the independent variables which is directly related to employees. For that purpose, we are considering masters, that is education we are considering, and gender also we are considering. Both are directly related to the employees. So we are checking is there any differences. Okay. Random intercept model with level 1 predictor. Okay. And here this is the null hypothesis. This is the null hypothesis. That is individual level predictors that we are checking: age, experience, education, gender, work-life balance, job autonomy, supervised support, and all those factors. Whatever we are using, all those factors are not significantly associated with the job satisfaction after accounting for organizational membership. Okay. If there is any differences between the organization variance, okay, what that we are keeping aside or as uh, fixed and checking is there is a differences in age, experience, education. Education we are checking masters, PhD and all, and gender if there belongs to male or female. Likewise, is these have changes? Will it make any differences in their job satisfaction? That we are checking here. Okay. I hope you could get a base on what is mean by random intercept model with level 1 predictor. Level 1 predictor means we are using individual level predictors, not with the organization, but directly related to the employees. For that purpose, initially, we are preparing categorical variables. Categorical variables means I hope you could know that what is mean by categorical variables. If we are giving masters 1 and 0, okay, that is okay. First code I will write here data. From data, we are checking education. We are making a new data to the data model education. Educator, education masters. We are creating a new data. Education master or masters, whatever it may be, is equal to if else. If else in the data, if there is a data like education equal, sorry, just we are giving equal to means the data in education directly to the data in masters will go. So in order to avoid that, we will use double uh, equal to masters master comma 1 sorry, 1 comma 0. What we are doing here, if in data set is there any data like education, and on that data set if there is a specific value like a master, then we have to create a new data set, new not data set, no, a new data that is education master. And if the master is present, then give value 1, otherwise 0. That means for the uh, graduation, we'll give the value 0, and for the PhD also, we'll give the value 0. Likewise, we are creating a categorical variable. Okay. Likewise, another one is education, same education, but with the PhD, we are creating a new data that is education PhD. The same way, that is PhD. If it is PhD, should give 1, otherwise 0. That is present and absent. That is the 1 and 0 it is representing. And for the gender also, we are using the same method. Data, gender, and if it is female, give 1, otherwise 0. Female is presenting 1, otherwise 0. That is for male, automatically the code will be going to 0, and for the female it will be 1. Okay. These things we are done to make the data into categorical variables. And next one is sender continuous variable at a grand mean. We are already said there are two methods will be there, grand mean and data age that is centered, and we are using the scale data age center true, scale false, and all the data in the age will be taken into this. That is a grand mean of age will be taken. Same way, experience also make into center value, average value. For that purpose, we are giving center true. And salary also, how much they are getting the salary. We are, for this analysis, we are making the average for that. Okay. Now we are created. The job satisfaction is already there. We are checking whether the age, average age, uh, average experience, whether they are education masters holding or not, PhD holding or not, whether they are female or not, work-life balance, how on an average, what is the work-life balance, and how much is the job autonomy they are receiving from their superior, and how much superior support is giving to them. All these are taken from the organization. Okay, this is the level 1 model. Okay, we are just running this level 1 model. If you could follow, just do it again. This I will tell you. From here we are started. Categorical variables we are preparing. It's a huge code. It may be difficult for you to follow on time. Anyhow, with the help of AI and all, we can create those codes. And data age, education we are created masters, if masters present or not, education PhD present or not, female PhD present or not. These are the categorical variables, and other variables we are used at the mean value. Why this education is not taken in mean value? Because it is purely categorical variables. Yeah, that is the base. I hope you all are known about that, those things. And here we are using grand mean of age. Age will be centered and experience is to be scaled, and also, sorry, not scale, centered, and salary also centered. And we are checking job satisfaction whether is related to age, experience, education master or not, education PhD or not, gender female or not, work-life balance, how much work-life balance they are receiving with their professional work and personal work, and how much is the job autonomy they are receiving from their top level and superior support. So by considering all these variables, we are make the model level 1. Then we are checking the summary of this model level 1. Summary model level 1. Level 1. Okay, level 1. I hope you could see these things. This was our code, and this is the AIC and BIC code. We are already said that it should be getting reduced from the earlier value. Then only we could consider this is the better model, and procedure values are checking. Okay, this is the most important things that we are checking. Okay, fixed effects. And intercept is obviously t value is greater than 2. This is the base for the analysis. If the t value is greater than -2 or 2, then only it is the variable is considered to be significant. Okay, I hope you know that basic things. And while checking the each variables, first one is age centered. Okay, their t values 3 point something, and the estimate is 1.01. That means if age is getting increased, their satisfaction is also getting increased, but at a minor increase will be there. And also the experience t value is also more than 2, so it is considered to be significant. And experience, if the experience is increasing, their satisfaction level is getting increased. Okay, so age and experience we are considered, we are found as significant. And also the education, masters and PhD. That means if they are holding masters instead of just degree, their satisfaction is getting hike. It is in a higher proportion, and PhD is more than to that. Both are significant. What is the real meaning of these two things? That means uh, we could interpret that if their education level is higher, automatically they may receiving some privileges than those the employees having lesser degree. So that's why masters, those who have higher satisfaction, and that is t value is higher, so it is significant. And PhD also they are getting more. Estimate is 0.65 instead of 1.4, 0.65 is there, and t value is also significant there. And gender female, gender has no significant influence. Work-life balance also no significant influence. Autonomy has no significant influence, and is supervisor support whether receiving or not has also no significant influence, because these are below the point, sorry, below the 2 or -2. Okay, and these estimates are also negative. That is also important. Female means if it is significant, if from the t value we could know that it is not significant, but if it is significant, we could conclude that female members is not satisfied, or their satisfaction level is lower than male members. And work-life balance also like that only. If they could not balance their work, professional work and family, they may get reduces the job performance. And autonomy also, if you are giving more autonomy, which is not leading to the uh, job satisfaction, but it is not significant, so we could not say like that. If it is significant only, all these points are to be considered. Okay, from these findings, or from this analysis, we could say that age, experience, and the education qualification, that is all these level 1 factors have a significant influence or impact on the job satisfaction. Okay, uh, this is the correlation coefficient is given here. Job autonomy, how it is related to the age, and supervision, how it is related to other factors. Okay, then we can check later, no issue. This is the second model, that is randomized model with level 1 predictor, and we are comparing the null model with level 1 predictor. For that purpose we will use ANOVA model null, and we are comparing with just the model we have done now, model level 1, model slash level 1. Okay, and if you are checking this, I'll make it bigger. ANOVA model level 1 and once we are identifying that this is significant. Okay, the chi-square value, 3 stars are there. Okay, so it is significant at a 1% level, 1% level of significance. The ANOVA is significant. And another thing, we are already said that AIC and BIC we want to check. In model null, AIC is 2641. But in model level 1, this AIC's value is getting reduced 2529. So we are already said that if this value is getting reduced, so the model is getting better. And BIC value also reduces from 2655 to 2580. So from these things, or from this ANOVA analysis, we could say that null model level 1, that is predictor at a level 1 is more better than null model. So up to model 1 we can go. Then we are checking whether what about the model 2. That is random intercept model with a level 2 predictor. Level 2 means that is not directly related to the employees but related to the organizational factors. Okay, here it will be the, okay, this is the analysis what we are already checked, analysis result, and what are the major findings we can create from this analysis that we are already discussed. Age and experience, and that is older and more experienced employees are slightly more satisfied. Higher education, masters and PhD has a substantive, significant positive effect. Job autonomy, job supervision support are strong, highly significant positive predictor. Gender, work life or not statistically significant, that we are already discussed. In the second model, level 2 predictors, random intercept model with the organizational level predictors or level 2 predictors. Here, this will be the null hypothesis, organizational level predictors, like size of the organization, whether it is medium size, large size, or small size organization, which type of leadership style they are following, and how much training budget is allocated to them, are not significantly associated with the job satisfaction. Okay, after controlling the individual level effects. So we are checking whether the size, the leadership style, and training budget has any significant association on job satisfaction. So we are using level 2 predictors for this purpose. So we are moving on to that. Okay. Initially, we'll create some some dummy variables. The first one is related to organizational characteristics, the same way what we had done earlier. Yeah, first one thing I will show you. Later you can do data dollar. We are creating a new variable, that is organization size, whether it is large. It is large is equal to if else. If else, I thought you know the function of if else. If else, in the data, is there is any variable in the term organization size, okay, organization size, then take as it is large. If it is large, should value be given as 1 or otherwise 0. So for the medium and small scale, initially it will given the value 0, later will changes. Okay. This is the one dummy variable. Likewise, we are giving for the medium size. So if both zeros are coming, that is considered to be small scale, small sized organization. And a leadership style, transformational style is there, transactional style is there, and a laissez-faire style is there. For that leadership styles also, we are giving the dummies. Leadership style, transformational, and transactional. The next one is we are standardizing the continuous numeric predictors. Why we are standardizing instead of uh, centering? That is age, experience, salary, training budget. All these may have a highly deviated values. In order to avoid that much deviations, not deviated entirely from different scale. Okay, age that maybe varies from 25 to 70 maximum or 65 like that only. But experience also vary from 0 to 24, 25 like that only. But salary may vary from 18,000 to 1 lakh or 2 lakh like that. So their value and the value in the age are entirely different. In order to avoid those conditions, we are standardizing the value instead of scaling. Okay. Data age standard scale data. Scale, scale. We are using the scaling. Then experience also we are scaling. And salary, what they are receiving is also scaling. And training budget for each department. Okay. This is the base what we are done. So initially we created or make use of all the uh, val predictors which is needed for the analysis. So initially we are created the dummy for size and for leadership style. Then we are standardized the age of employees, experience, salary, and training budget to for department. Okay. In this case, we are using level 2 predictors, which means we are adding uh, in departmental factors to the model. Model 2, LMER, job satisfaction, tilde, that we are checking standard age, standard experience, education masters or not, education PhD or not, their gender, work-life balance, job autonomy score, supervisor support, organization large or not, organization medium or not, and leadership styles, transformational or transactional, or if both are automatically license where will comes. And what about the training budget? This is all these factors we are moving to checking with the job satisfaction. That is model 2. Yeah, we can run this model. Once we are run, we'll check the summary. Summary. Model and slash level 2, second level. Yeah. Okay, we are just showing that correlation matrix not shown. In the earlier stage, below a correlation matrix is given. Normally, the range for correlation matrix is 12. But here in this model, we are using 14 items, independent variables. Due to this, R is unable to run the correlation matrix. That is shown here in the below. Not an issue. Okay, while we are checking the fixed effects and all, from these things, age is significant, we could find, and experience is significant. Then education masters is significant. Here, organization size is almost significant. Then, yeah, transformational leadership style has a significant influence. Budget is significant, but not that much significant, because if it is greater than 2, we could say that is significant influence, but here is just below, just above the 2. Okay, anyhow, this budget also has a significant influence. Uh, from these things, we could conclude that um, both organizational level factors also have a significant influence association on job satisfaction. Okay, because this size is not that much significant, but uh, training budget has a significant influence. Uh, this one, organization size, whether it is large or not, has a significant, is below the point -2. So large size has a significant. This we could conclude that both most of the individual level factors, level 1 factors and level 2 factors like size, budget and all, has a significant influence or effect on the job satisfaction. So both the individual levels as well as organizational level factors has some influence. From these, only one we are considering just for identifying the how to write an interpretation. Training budget. If the training budget is getting increased, the estimate is positive. That means their satisfaction level will be getting hiked. How it is happening? If training budget is getting increased means, or more budget is allocating for the training means, while the employees are going for the training, they will get more leisure, more worthy classes, or more worthy food and all. So that if the organization is increasing the training budget, that leads to the organizational satisfaction, employee satisfaction. Okay, and likewise all other things we can find, or here work-life balance is negatively influenced, and size is negatively influenced, large size, which means that if if the organization is large, their satisfaction level is getting reduced. Why it is happening? It may be, we are not aware about that. It may because of, if in the large organization, large scale organization, they may have more work to complete. That may be the reason, I don't know. We need to check the literature and all, then only we could conclude that. But this may be the reason from our analysis. Okay. Every time we should keep in mind that while we are making any interpretation, it should be followed by the literature, not only with the analysis. So this is all about the level 2 predictive model, and we are checking comparing the level model level 1 with the level 2. Is there any significant change? If there is no much changes, then it is not worthy to go for the higher level models. Okay, model level 1 comma model / level 2. Okay, you could say that this p-value is significant. So model 2 and model 1 has a significant change. And while checking the AIC and BIC, model, in case of AIC, it is somehow get reduced, but in BIC, the value is getting increased. So we could not say that there is a much better in the model level 2. But anyhow, there is some differences in the model 1 and model level 2. from the ANOVA. Okay, next we are moving on to random slope model. Next model, we are checking effect of supervisor support varies across organization. Varies across organization. Okay, this is our null hypothesis. That is, the relationship between supervisor support and the job satisfaction does not vary significantly across organization. So we should be very clear that we are checking whether the supervisor support is leading to job satisfaction or not, and whether this job satisfaction is varying from organization to organization. Okay. So initially we are identifying supervising support has a significant influence on job satisfaction and whether it is varying from organization to organization. Okay. For that purpose, uh, we are given a name that is model random slope, then LMER, job satisfaction tilde, age, experience, education, master, PhD, gender, work-life balance, autonomy, supervision support, organizational size large, organization medium, leadership transformation transactional, all those things were already given. And here we are additionally we are saying supervisor support. We are creating in another variable in between these two relationship organizational, sorry, supervisor support, and checking whether the supervisor support due to this supervisor support whether their job satisfaction is increasing or not, and if there is any differences in different organizations. Okay. Just I'm running this code, not writing because the time is already getting late. And summary, we are taking the summary. We are identifying some of the variables are significant, and supervisor support is not significant exactly. And overall score is checking AIC and BIC is getting increased. That is not a good for such cases. Okay. Anyhow, we'll check the ANOVA and we are comparing different models. Comparing ANOVA with level model 2 with this random slope model. ANOVA model level 2. That is, we are taken organizational variables into this and model random summary. Sorry, random slope. Okay. Okay. Initially, we are checking the p-value. It is more than 0.05 and it is not significant. That means if you are checking the random slope, it has no much differences from the level 2 model that we are already taken just before the random slope model. So what will be our conclusion? If you are checking, is there any significant changes between the organization based on their supervisor support on the job satisfaction has no significant influence, or it is not significant, or the it is not significantly varying from organization to organization. This is the conclusion we could find. So if you are rejecting the null hypothesis, we could take a random relationship between supervisor support and job satisfaction varies significantly across different organizations. we could not find those result, and there is no much differences. And while we are checking the AIC and BIC value, we'll check model level 2. AIC value is 2507, but here it is increased. The best model is if the value of AIC and BIC is getting decreased or reduced. In here also, in the case of BIC also, 2582 is getting increased to 2595. So we could conclude from this analysis, we could conclude that it is not better to go with the random slope model. Better to stop with the level 2 predictors, where level 1 and level 2 predictors are combined, and it is not better to go with the random slope model. That is exactly, we are checking the differences from organization. Organization is not as much not significant. Then once we are concluded those things, it is not recommended to go for the higher level models, but anyhow for the identification purpose or just to know how to do those things, we are just checking cross level interaction model. What is the cross level interaction model, or what hypothesis we are setting in cross level interaction model? In the null hypothesis, we are saying that leadership style does not moderate the relationship between supervisor support and job satisfaction. That is, if the supervisor support is getting, and whether it is leading to the job satisfaction, how the leadership style is different, moderating this relationship. That is, if it is a transformational leadership style, how the supervisor support leads to job satisfaction. It is transactional leadership style, how this relationship is changing. If it is license where leadership style, how the supervisor support is changing to job satisfaction. That is crossover interaction model. But it's normally, we'll say, if it is failed in the random slope model, or a random slope model is not identified as a better, then it is not better to go with the higher level models. But just for identification purpose and all, we are just doing these things. Directly I am giving the code. Here we can say for taking the moderation, supervisor support into leadership transformation, supervisor support into leadership transactional. Likewise, we are giving the code, that is moderation analysis, mediation of moderation. I hope you have some idea. Moderation means how two variables relationship is moderated by an external variable. Here this is the leadership style. And we are checking the summary. Some of the variables are identified to be from the t-value. You could identify to be it is significant, but an overall whether it is acceptable or not. For that purpose, we are using the ANOVA model, random slope and random interaction. Yes, this is not much changes. The p-value of the ANOVA is not significant, more than 0.05. And while checking the AIC also, it is increasing 2510, it is increasing to 2512, and BIC value also getting increased 2595 to 2602. So from these things, we could conclude that this random model and cross-sectional model are not recommended to do in the hierarchical linear modeling. Instead, we can stop in the level 2 predictors. So where we can add individual level model level 1 and organization level model 2. Okay, it is not better to take the changes and moderation analysis. Okay. This is all about the hierarchical linear modeling base. And for model diagnosis, we can use QQ plot and all. I hope you could see here. QQ. Almost most of the variables are in the line itself on the top, and in the below some of them variables may varying, but uh, most of them are following the normality. And finally, we are making a model comparison because we are done null model, level 1 model, level 2 model, random slope and cross level models. We are creating a summary table. Uh, Before saying that, this QQ norm and QQ plot, we will check if it is a significant deviations from uh, the values. It is recommended to increases the sample size, or the sampling method should be more uh, randomized. Then these things can be getting to be corrected. Okay. In this case, most of them are following the normality, and most of the variables, on an average, it is in the scaling, not scaling. It is on the uh, clear area on the top, and on the below. Some of the variables are only deviated. Then create a summary table with the null model, level 1, level 2, random swap and cross level, where we are using AIC and BIC values and likelihood values. Okay. They created a model comparison, then print model comparison. Okay, if you could see this thing. Null model AIC 2641. Level 2, it is getting decreased 2500. Then again, it is getting decreased in level 2, 2507. But in the random slope, it is getting increased, and cross level also it is getting increased. And likewise also BIC score, likelihood, it is up to this level, it is increasing and all, but later there is no much change. If you are checking this value, minus 1237, the same value only be in the random slope, only a minor change, and here also cross level also there is only a minor change. So we could not say that if you are going with a random slope or cross sectional model, it is not recommended in the hierarchical linear modeling. It is better to stop with the level 2 models. Okay. From where you can use the AIC and BIC. From this, we could say this is the least AIC and BIC is created. So we will stop with the level 2 models. Okay. Level 2 models means we are adding the organizational factors also into the regression model. Okay. This is all about the very fundamental analysis of hierarchical linear modeling.
Excuse me, sir.
Yes.
Sir, the topic is very interesting, but then the clock is ticking away.
Oh, it's okay. It's okay.
Yes, sir.
So I'm just stopping now. I hope you get some idea on what we have done and all. With this base, you can create more ideas. And I really thank all those who are present and very sincerely hear my topic discussion. Okay, if you want to add anything, or you know, if you have any doubt and all, you can contact me over the WhatsApp or email. This is my contact details. Okay, thank you all.
I request the participants to put up their queries or any questions if you're having, or else sir has already shared his contact details, so you can connect to sir at this point of time, if you're not, able to understand what your queries can be, then you can connect to sir later on as well. As sir, I'll request sir to share his PPT so that, sir, if it is okay for you, you can share the PPT, then we can
Yes.
give it to the participants.
Okay, I will share with.
Sure. So, you all can go through it as it's a workshop. So it is always good that we learn some things which we will be able to use in the future period. So over the last 4 days, our participants have attended multiple sessions and they have learned a lot. But then when it comes to application, so many things might not be grasped well so that they're able to apply. So it might need, they might need time for that. So the PPT will be forwarded to you. In case of any doubts, sir is there to help you out. So thank you so much for sparing your valuable time to be here with us today. That is, very important for us that we are able to, bring the best so that our participants are able to get the best knowledge, the experienced people. So, sir, here's sharing a certificate of gratitude.
Thank you.
So in the future as well, we'll be connecting to you, organizing such sessions. We hope you will spare your time then as well. So thank you so much. And I request the participants to raise your queries, doubts, if any, to sir. Sir has shared his number already. Thank you so much, sir.
You're welcome, ma'am. Thank you.
Now I want to inform the participants that our next session will be starting at 2 o'clock. And just the session, as the session gets over at 4 o'clock, we'll be having a valedictory session. Sir, I request you as well to be there in the valedictory if you can spare your time. We'll be starting at 4 o'clock.
Okay, okay.
So all the participants, you can break out for lunch and then please join back at 2 p.m. Just after the session gets over, our second session, we'll have the valedictory. Thank you so much. So I request Dr. Khangeman Jiten Kumar Singh to, make us learn or enrich our knowledge base with the topic spatial data analysis using R. So we welcome you and I hand over the session to you. Sir, please unmute yourself. Yes.
Now it's audible.
Yes, sir. It's audible.
Thank you, Dr. Aruna Dev, and good afternoon to all. So today, I think today is the last sessions of the 5-day training workshop, and this will be the last session. Okay. So last session is a special session, right? The important session. So I am going to take over this 2 hour on the topic of the spatial data analysis using R. So spatial is a special, and this session is a special. Okay, right. So in any research, we need the space or location. When we come to this location in space, there is nothing but where I am standing, where I am living, or where the household is living, or where the market shop is staying. That the location, that is space. So this word space or location is come from the geography side, from the geography subject, and is integrated in the research. Traditionally, in our statistics, we are doing only for the data analysis without taking the importance of the georeference. Nowadays, in the research, in any kind of research, environmental research, economic research, or the chemical research, health research, and population research, if we are going to include the georeference in the data, then that is a part of the spatial analysis. Means in the data, we are going to incorporate the locations where the peoples are living or where the data is come from which location. So that is why in the research, the location is a very important. So this is a one example in the area of health. So if we want to know the distributions of the disease like cancer, different types of cancers are there, mostly cervical cancer, breast cancer. These are the leading cancer among the women. So we want to see where is the high prevalence geographically in which district. Then we have to include in our health data, we have to include the georeference. Then after that, we can see the distributions of the prevalence of the breast cancer. Then we will understand, oh, Dibrugarh side, the Dibrugarh district is a high prevalence with compared to the Nalbari and Mangoldoi and Kokrajhar side, because in that side the prevalence is showing less prevalence, but in the Dibrugarh side and Sibsagar side and the Golaghat side is showing the high proportion, high prevalence. So this we can see in the map after incorporating the georeference in the health data, in the cancer data. So similarly, in the environmental, in the chemical, in other things, in the economics also, you can do it in the business management also. You can apply all these things. Only thing is in the data, you have to include the georeference. That is a concept of the spatial. थोड़ा क्लास स्टार्ट किया अभी just now. Okay, so understanding of this, where is word? That word is very important word in the research. Before including the georeference data, we are asking why. Then traditional statistics is giving the answer why. And what is the cause? That also giving from the traditional statistics, and how much and what. So all these questions are answer is by the traditional statistics tools giving the answer of this why, how, what, all these things. But where? The answer of where we have to give through the spatial. So that is why the space, that location is very important in the research. Now when we entering to the spatial analysis, some techniques are there. The first technique is what? We have to see the geographic patterns. It is randomly, or it is a separate, or is a dispersed by the district wise. That is a part of the geographic pattern analysis. And we have to see what is the clusters of the disease incidence or disease proportion. And then the changes in the year by years, we can see. That is the cross-sectional time series we can put in the visualized form. The second point in the spatial technique is identification of the high risk area or high risk village or high risk cluster. Say our prevalence of the breast cancer among the women is very high in Dibrugarh area, but within the Dibrugarh area, where is that? That is the identification. That is in the second level of the layering. The first layer is the district level layers. The second layer is where is that? That may be in the eastern side of the Dibrugarh, or it may be downside in the western side of the Dibrugarh. Where is the dead village? Where is the high hotspot area that we can identify through the spatial technique? And after knowing all this, the distribution, after knowing the patterns, after knowing the each and every year's intervention is in every year increasing trend, then you can allot your resources where you have to allot, where you have to give the intervention. So this decision you can take it from the analysis region of the spatial technique. Now, coming to the foundation of the spatial analysis. Two terms is very important. One is the geocoding. Another term is the GIS, georeference. Geocoding is nothing but your address, or you are sitting in the RGU, in that conference room, or in that hall you are sitting. That is your address. That address, that location, you will get it your X and the Y, the georeference. That is longitude and latitude. In the same way, I am sitting in Delhi in ICMR headquarters in my rooms. So here also one location is there, X and the Y. So this X and the Y, my X and the Y and your X and the Y, these are what we call it a georeference. So this georeference is, if it is in the form of the address, then we can convert in the using the geocoding, we can convert in the georeference. If it is already available in the Google's or somewhere in the mobile, then you can capture it. One example is, suppose you have the mobile and you are going to the Nawang town, in the Nawang Bazaar, then you are taking some data in the one of the village. In that village, different households are there, 20 households are there. Then you are opening your mobile, then all the 20 household, then you can capture the georeference through the mobiles. That is what we call the geotech. So we have captured the georeference of that 20 household of that village residing in the Nawang. Or otherwise, the address of the household, the name of the para, name of the locality you are noting down in the questionnaire or in the paper, then from that questionnaire, from that schedule, then you can type entering in the Excel sheet. And from that Excel sheet, again, you can code you will get the georeference. That is another technique for the text, from text to capturing of the georeference that we can learn in the Excel through the CSV file. Now I am coming to the GIS, Geographic Information System. This is a very powerful software. It will capture your georeference and it will be stored, and data can be analyzed, and then the geographic data are stored in the GIS through the GIS system. And different institutes, they have different GIS divisions are here. Remote sensing in Dehradun, that is another one institute. NIC in Delhi, they are also collecting all the data and storing there. And administrative boundary of the districts, or the administrative boundary of the block, administrative boundary of the village, these are all available. But some are available in the public domain, some are not in the public domain. Okay, so through this GIS, then we can visualize the patterns, what you are collected the data, and then you can see the relationship. This relationship, the last line, what I have written, the relationship, it is similar to the correlation. In our statistics, the simple statistics, that is the correlation between the X and the Y. But here, the relationship is not in that way. This is the correlation between the value of your data and then geographic difference where you are residing, where you are sitting. The correlation between your data and the space, that is the relationship. Now, trend. Trend is nothing but this 2025, we have some data, and 2024 previous year, we have another data, and 2023, 2 back years. So similarly, we can have from the 2022, then 25. So for each and every years, we can see the trend in the map, not in the bar graph, not in the line graph. That is the simple cross-sectional trend. Here is, we can see the trend in the geographic, in the space. What is the trend? What is the changes in the color? That is the trend. So the first one is a pattern. The second is a correlation of your value and then space. And next is the trend. Trend is nothing but data and the time and the space. So what is the spatial analysis? Just now we have discussed about the relationship, pattern, and trend. So from there, the definition is coming. It is a set of the technique to examine the locations and to examine the patterns of the data, and trying to find out the relation between your value and the space and the trend of your spatial data. That is the definitions of the spatial analysis. So in spatial analysis, we should know some of the concept. So I have written down here the 5 concepts. Number 1 is the location. Location is nothing but the coordinate or georeference. Where you are standing, where you are sitting, where the people are living. That means in the address and where the thing is happen. Where is the that breast cancer, that woman. Next is the distance. The distance, when we come to the distance, it should be at least the 2 points. The point A and the point B. That means one woman living in the Nalbari and one woman living in the Dibrugarh, and one person is having the cancer positive, one person is not having the cancer, that is the negative. Then we are looking all these things. Then we have so many points of the women. Some are positive and some are negative about the cancer. So from here, we can find out the distance, and the distance visualization, we can do it. The third one is the spatial pattern. In the pattern, we are looking for what? Is the pattern is random, or is the pattern is the cluster? We are important to find out the cluster. Where is the hotspot cluster? Where is the cool cluster? So the first one cluster is important. And then the last one is the evenly spread out. That is nothing but we want to see all the data are in the same line, or in the group wise, or in the one line, or in the triangle line like this. That means in the colony, in Guwahati, in one colony, the all household are in the one line, in the one lane. And the second lane, all the household also in the one line, one by one, one by. Same in the pattern. That is the evenly spread out. That is the one of the example of the this spatial pattern. So in the spatial pattern, we will have the cluster, random, and the spread out. And our important is to find out the cluster. What is spot cluster and good spot cluster. Now coming to the relationship with the spatial, that is nothing but the influence of each other with the area. And then the last one is what? The spatial dependency. That is what we call it autocorrelation in the spatial analysis. This is similar to the what the definitions of the correlations, Partial correlation in the statistics. Here is one auto is added. So that is why autocorrelation. What is the autocorrelations? Here is the locations are more similar than the distance one. What is the meaning of this? Suppose in a Nawang, around 20 villages are there. In Nalbari, another 20 villages are there. So the location nearby to each other, they are having the same different types of characteristics, the similar characteristics. In the Nawang also, they are having the some different types of characteristics. Say in the Muslim area, all the 10 Muslim area one by one, so they are having the same type of the characteristics among that populations. Their food habit, their living style, their religions, whatever. So nearby is influenced by that point. So in the Nalbari, so that one village is surrounded by the other village. So other village also same having having the same characteristics. So that is why that is the spatial dependence. If it is not dependent, means if it is totally different from one village to another village within the Nalbari, similarly in the Nagwang also, one village is totally different from the another village in terms of the characteristics. That is, there is no autocorrelation. So that we can find out through the data along with the georeference. So this 5 is very important, and for the statistics, we have to find out the spatial pattern, spatial relationship, and the spatial dependency. If the spatial dependency is there, and then we have to go for the regression analysis, logistic regression, and linear regression. In that regression, again, we have to incorporate the dependency term. That is why the spatial regression is different from our traditional regression analysis. It will come after these few slides. So the spatial data analysis, here that some common techniques are that first we have to see the visualization, and sometimes you have to separate, or you have to extract the data. Data is in terms of the spatial. How to merge the two states, or how to separate Assam state from the India, all over India states, or within the Assam state, how I can extract the one district of Assam, the Dibrugarh district. So this is a part of the data management. These are, and then after that the visualization, all these are coming under the description part. And then exploratory of your data, then you are going to apply the statistics part, hypothesis testing, and the same other analysis you can apply in the data along with the georeference. Then after that, you can see the modeling. Modeling is nothing but the regression analysis. Once your regression analysis is over, then you can find out, you can predict from your model, and then you can see which model is the best model, and then from that your best model you can predict, taking the other data, you can predict it for the future and for the forecasting. So one important of the basic in the geography, now coming to the health research, that is GPS, global positioning system. That is, I have already talked about the georeference. That is in the red color in the glove, that is the X and the Y. So you are all sitting in the one hole in the RGU, then you have one X and the Y of the RGU, that place, that is your georeference. So that X is nothing but that is your horizontal line, that is represented by the longitude, or in terms of the data, that is the X or the sting. When the value of the X is increasing, then suppose you are in the RGU in your campus in Guwahati, when the X is increased, the sting is increased, that value, then you will go to Tezpur, then Nagaon, then Sibsagar, then Dibrugarh, then Arunachal Pradesh, when you are increasing. That is in the horizontal line you are increasing. When the horizontal line value, the X value is decreasing, then it will go to the Nalbari side from your Guwahati, then the value is decreasing, then it will go to the Nalbari, then it will go to the Kokazar, it will go to the Coach Behar side, like this. So that is play in the horizontal line. So another one is Y. Y will go up and down. That is the vertical line. So that is similar to the our y-axis in the Cartesian coordinate. The y is northing. So when you increase the value of the y, it will go up to the north pole. When your y value is down, again decreasing, decreasing, it will go to the south pole. So this x and the y play the georeference. Coming to this GIS in the spatial, we have some common type of the file. The shape file is very important. When we want to do the spatial analysis, then first we have to collect the spatial data, that shape file. That is important. You have your statistic data, what you have collected your through the questionnaire or through the Google's, you have the data. That is your for the data analysis purpose. That is the data. Now you need one spatial file, one spatial data. That is what we call the georeference data. And then after that, your data and the spatial data has to be merged it together. Then you can start your spatial analysis. So now coming to this your spatial file. Within the spatial file, there is some basic files are required. That is written here, the shape file and the tables and layer and then the geo database. So this 4 file is very basic one. So in the shape file, I have written here the point and line and polygon. The point is nothing but that your georeference. I already talked one georeference. I am sitting here in Delhi. I have one georeference. Then you are sitting there in the RGU in the hall, and you have one georeference. So in this example, we have the 2 georeference. One is my georeference, one is your georeference. That is the georeference point. Another next is the line. Line is nothing but from Delhi to Guwahati, there is a train line. That is a line. Or the Brahmaputra is coming from the Arunachal Pradesh, then coming to the mid of the Assam and is going down to the Djibouti, then it will go to the Bangladesh side. So that river is a one kind of the example of the line. Now coming to the area, that polygon. Polygon is what we can say that the polygon is one point is start, then another point is making the area and joining in the first point. That is from the geometry. So that is a polygon. Now coming to the application part, in village boundary is there. So that village boundary is a polygon. District. Dibrugarh also having one administrative district boundary. That is a one polygon. Nawang is also having the one administrative boundary. That also one polygon. Nalbari district, that also having one administrative boundary. That also one polygon. That means you have some district in Assam. So let's say the 33 district in the Assam. Then you have 33 polygon. For the analysis purpose, from the statistical view or from the statistical side, but we require the points and the polygon. Mostly analysis is in the point and the polygon. And the DBA file and Excel file is the data file of the instances values of the points of that area, and the layer, the first layer, second layer, third layer, and fourth layer. So layer is nothing but I am explaining you. Village is a one layer. The village data is a one layer. Above the village, there is a one block data, block administrative block. That is a second layer. Then above that, one district administrative area. That is another layer. So three layer we have. Then another four layer is one state boundary. That is the four layer. Above layer. Then another one is the whole country, India country, one boundary. So these are the kinds of the layer. And the geo database, it is come from the geo reference point. So WDS or some things are there. Now, this I have already explained. Again, I'm coming to this data, the spatial data. Spatial data, point, line, and polygon. So point, line, polygon is a part of the vector data. Another one is the raster data that is in the grid. That is nothing but the collections of the point or the collections of all the rectangle cell organized in the form of the regular lattice. That is the grid. Mostly what we are using is data is point and the polygon. Line also not common. Though for all this spatial data, we consist the positional information is already there. And then when you are asking in the research, where is that? Where is that happen? Where is that breast cancer prevalence? All the answer will give you through this spatial data analysis. That is why where it is, you are asking where is it? It can be in the economics also, it can be in the business also, it can be in the any terms, any discipline. Where the question asking where is it, then answer has to give through the analysis of the spatial data. So here point, line, polygon, and grid, and this is the example of these four spatial data. Point, line, polygon is a vector. Grid is a raster data. Now we have our data and we have the spatial file, spatial data. Both are available in my hand, available in my computer. Now I want to start the spatial analysis. So for spatial analysis technique is not a simple one. It is some concept is there, the base, and it was introduced by the Tobler. So that Tobler concept is known as the first law of the geography, that is in the 1970. What he said, everything is related to everything else, but near things are more related than the far distance one. That is the main concept. If it is related, if something is relation, that is a spatial dependency, spatial autocorrelation. If spatial autocorrelation is there in the data, then whatever you are doing the regression analysis, whatever you are doing the statistics analysis, then you have to include the geo reference, you have to include the spatial data. Otherwise, there is some issue in your analysis region. So that part is coming in the next slide. So this is some few types of the spatial analysis. Number one is a descriptive mapping. we are going to look the choropleth map or the polygon map visualizations of the yours prevalence of the breast cancer among the women. Where is the high, where is the low visualization you can see. The second thing is we are going to identify where is the high prevalence cervical, high prevalence the breast cancer. The third one is there any spatial correlation with the prevalence of the breast cancer among the women, and then space where they are living. We want to see. Then you have to apply the spatial autocorrelation. If the autocorrelation, spatial correlation is very close to 1, that R value in the statistics, in the correlation, R value is close to 1, that is the positive correlation, and R value is very close to the -1, that is the negative correlation. If R value is 0, that is no correlation. Similarly here also in the spatial autocorrelation also we have to see the Moran eye, and we have to see what is the value of the that Moran eye. If it is very close to 1, that is a spatial correlation is there. If it is 0, no spatial correlation. If it is near to the -1, then it is a negatively spatial or autocorrelation. So Moran eye is a globin. It is showing only the globin, and then next is the common one is the Lisa Loken indicator spatial autocorrelation. Now, once the data is correlated with the space, then you have to apply the spatial regression, not the simple regression. Same thing, logistic regression also, you are having the spatial effect, then you have to use the spatial logistic regression analysis. There is another formula, another code is there. Same thing in the early morning, you have learned about the multi-level modeling, the hierarchical data analysis. Hierarchical is nothing but you are living in the one village, that village is under the one district, that district is under the one state. So 3 layers are there, that is a hierarchy. So you are clustered within the districts, and the district is clustered under the states. So that is a hierarchical. In the other sense, that is multi-level. You have the 3 levels. That is another random effect, you can capture it. But in the spatial analysis, you are having relationship with the space or with the neighborhood. Neighborhood means another districts, Golaghat, or another districts, Shivsagar, or another district in the Karbi. So that is the neighborhood districts. So neighborhood districts also you are giving the influence, that neighborhood effect. But in the multi-level analysis, it will capture only the higher level-wise capture, but site-wise the neighborhood is not captured. The neighborhood influence is not captured. But in the spatial regression analysis, you can capture both. That will come in the next. That is hierarchical also you are going to capture, and the neighborhood also you are going to capture. That is a one special analysis of the hierarchical spatial regression analysis. Okay, now I am coming to the number 5, geographically weighted regression analysis. What is that? That is only the regression analysis, the term geographic and weighted. So each and every districts in the Assam, there is some weighted also there with related to the your space and your data. and geographically these are varies, and we are going to assess the relationship of your cervical cancer proportions and then your space across all the districts, and that can be done by the techniques of the geographical weighted regression analysis. That example is coming in the next PPT. Then after that, interpolations. Okay, so once you have the data in your hands along with the spatial data analysis, that spatial data, then you can start the point data analysis, you can start the aerial data analysis, or you can start the geostatistical data analysis, then spatial modeling, and then spatial forecasting. All these things you can do it. Now, nowadays, the machine learning also coming, and then we can integrate the machine learning along with the spatial data. That is advanced in the advanced part of the spatial analysis. Integrations of the machine learning in the spatial model. Now, the basic concept in the flow charts of the flow charts of the spatial analysis is we have the 3 steps. Number 1 is what. What is nothing but descriptive analysis. We are looking for what is going on, what is the event. The answer is the proportions of the breast cancer. That is the what. Where? The where is going to give the answer through the spatial analysis, and the how and the why, that can be given by the spatial modeling if you are incorporating the spatial data in the analysis. If you are not incorporating the spatial data, then how and why answer can be given by the traditional regression analysis, like the simple logistic regression, like the probit analysis, like the Poisson regression analysis you can give. If where is included, then you have to apply the spatial regression analysis. So in any area, suppose you are in the econometrics, then in the econometrics you are bringing the spatial data, then that is the spatial econometrics. In the medical, if you are putting your spatial data along with the health data, that is the spatial epidemiology. You are the population researchers, then you are integrating the spatial data, that is the spatial population. So like that, the different names are there on the basis of your subject, on the basis of your discipline. Now, some overview of the spatial technique: methods, purpose, and tools. Spatial autocorrelation, that is the name of the technique. The purpose is detecting the cluster, where is the hot spot, where is the cool spot. That can be done through the using the R, or using the Stata or Geoda. Geoda is a one software that also freely available, and R is free available. Stata is not free available. Stata is the process. In the Stata 18 and the Stata 19, you can do it. Hotspot analysis, that is the local indicator spatial autocorrelation, or GI star. GI star is very common one to identify the hotspot and this thing. This can be done through the I, R, and the ArcGIS, not in the Stata, not in the Geoda. Spatial regression, that is adjusting of your spatial dependency in the regression analysis. That can be done through the R, Stata, and Geoda. Geographically weighted regression analysis, that one software is coming, that is a GWR4. And in the R also, in the Stata also can be done, but it takes some time. So another one free software is there, that is the GWR. geographical weighted regression version number 4. And the spatial scan, that is the ST scan, and the spatial temporal, when you want to include the time point, at least 3 time point, then it will be the spatial temporal analysis that can be done through the R. Now, in the spatial data analysis, what you need, some concepts of the neighboring. Some concept of the neighboring, that is the distance and the neighborhood and the interaction. Now I am coming to the basic concept of the weight. So weight is nothing but come from the what the neighborhood one and another neighborhood polygon, another district, how they are touching in the boundary. So another one, the first one is the rook and the second one is the queen. Queen is nothing but everything, the edge and the boundary all are touched. But here in the rook is only the corner is touched. So hexagon everywhere is touched. Then irregularity. So different types of touchings are there in the neighborhood. So that will, this idea will come when you are calculating the weight. Weight is nothing but for the analysis of your regression analysis in the spatial. So first order and the second order, rook, hexa, and queen, different types of the weights, but the different layers are there. First order, second order, and third order, like that. So this is one example, one formula for the GI star. It is very important formula. This is nothing but similar to our correlation formula. It is a extension of that correlations formula, including the spatial weight and the distance. Using this GI star, we can find out what the hot spots, red color, green color, and some dull color. The red color is one village, green color also one village, and then all the points are represent for one village. All points are represent one village. So for each and every village, there is some proportions of the value. So this example is regarding the smokeless tobacco use among the women in the northeastern states, India. In Mizoram, so all women in the village or in the urban, whatever in the points, the prevalence is high, and it is showing all are hot spot in the Mizoram. Similarly, in Assam, somewhere in the Hailakandi and this Karimganj and Silchar. So in that particular 3 districts, they are showing the high prevalence of the smokeless tobacco use among the women. Now coming to this Meghalaya, so in the Khasi area and the Khasiya Jaintia area side, the all are red color, but in the Garo side, the all are green color. So from this cluster map, what we can say is that in the eastern, this Khasi side and Jaintia side, the smokeless tobacco use is very high among the women. Similarly, in the Tripura also. So this is one kind of the spatial analysis, and it is used only for the visualizations of the hotspot cluster using the technique GI star. This is the formula for the GI star, and this can be done in the GIS or in the R, not in the Stata, not in the SPSS. So the technique GI star we can apply when the data are available along with the geo reference. Then you can do it all these things. then you can publish or you can do the dissertation, and from this analysis region it be analysis region it may be useful to the health people, the medical people. They may use all this for making the policy maker of the health intervention. So I am taking here two examples. The first one is regarding the kidney disorder. The second one is regarding the asthma among the children. So after looking this thing, we can draw it some of the research finding. So here we can use the GI star to identify the hotspot clustering. Similarly, this is for the cesarean sections, means delivery through the cesarean. Somewhere here in the Guwahati and Mangoldoi area, then Uldarkori area, and some part of the Nalbari area, all are red color. That means those women who are delivered their children, their baby, mostly they are doing the cesarean section. Maybe some other factor, maybe they are very close to the hospital, the big hospital and the big private hospital. Similarly, here in the Dibrugarh side also, they are giving more prevalence cesarean section. In Manipur, all the prevalence are highlighted somewhere only in the valley area. That means in the valley area, in the Imphal East and Bisempur, all the hospitals, all the big private hospitals are located only somewhere in the Imphal area. And the most populated area also in these people. And educated people also there among the women. So they prefer their delivery through the cesarean. So the evidence also coming here from the National Family Health Survey data. So in the National Family Health Survey data, I was there as a senior research officer in IIPS Mumbai almost around 6 years. So I have visited all the each and the corners of the whole northeastern states. I spent around 5-6 months in the whole districts of the Assam. So I am aware about the area and the village name and the district name, sub-district name of the Assam, and similarly for the other states also. So here in the NFSS data, georeference is captured. When we go to the field, we capture the georeference for that particular village, not the household, particular village. One village, one georeference, one village, one georeference, one village, one georeference. So here we have almost around 44,900 something villages are covered in all over the northeastern area. Then the questions are, what was your mode of delivery for the baby? Then answer is coming. Now from this data and this spatial georeference, then we can use this type of the analysis. Similarly, this type of analysis you can apply in the economics also, you can apply in the business also, you can apply in the environment, and also you can apply anything. Only thing is you need one data and you need the spatial georeference data. After having these two data, you use the GI star technique, then you will find that your clustering identifications of the cluster. It is very useful. And now another one is LISA, local indicator spatial auto-correlation. The previous one, this is in the point. This is 1 point, 1 location, 1 point, 1 georeference, 1 village, 1 georeference. Here is the polygon. Here is the polygon, point and polygon and line. Line is not useful for the analysis purpose, point and polygon. So this is one example of the polygon. So in this example, the left side is just the prevalence map of the instanting among the children are just visualizing. That is the color map, or in the other side, this is the polygon map. But in the right side, we are doing the statistics of the univariate analysis. The above one is the above top corner of the right. This is the local indicator spatial analysis region. From this analysis region, we can understand somewhere in the Khasi and the Khasi side, in the eastern part of the Meghalaya, the instanting is very high. It is nothing but what? In the Cherrapunji and the Masuram side, the altitude is very low, and all the times the rainfalls are there. Throughout the year, rainfalls are there, and their living conditions also very poor, and they don't have any the health facility also. So many factors are there. So all these are coming here evidence of the stuntings among the children. And one part here in the Assam, the Kokazar side. So there also is coming the hot spot. And this hot spot is using the technique of the local indicator spatial autocorrelation. That is the LISA. This is a simple univariate analysis. That means your only outcomes. Bivariate analysis also there. Means bivariate means your outcomes and another one variable, two variables you need for the Bible, right? So this is the trend from the NFSS 5 and the NFSS 4 with respect to the NFSS 4. So the stunting is still persistent in Meghalaya. The before the 5 year, that is in the 2015 and 2020, there is no changes in the stunting, in terms of the stunting in Meghalaya. So the data is showing here, and we publish the paper. Now I am coming to the regression analysis. See, the traditional regression analysis is morning also you have already done the regression analysis, and that was particularly for the multi-level analysis, hierarchical. Now, the simple regression analysis is outcome, then intercept, and your x1, x2, x3. That is the vector of your independent variable. That is the covariate. Then error term. Now, coming to here, this in the B part, what I am showing is that not only your intercept, not only your vector of the covariate, I am putting as the random effect. Random effect is nothing but your multi-level, your hierarchical effect also capture, plus the spatial effect. Spatial effect is nothing but the neighborhood of the one village to the another village, or one district to the another district. So that is the neighborhood effect, and another one is the hierarchical effect. These two can be captured, can be incorporated in the regression analysis. That is a special type of the spatial analysis. And this is one example of the geographically weighted regression analysis. In the regression analysis, you have R square. In the morning also, you have already known that you understand what is the R square. So the proportions of the value given explained by your independent variables. If it is 7 or more than 7 means 70% or 80%, 90%, your model, your regression model is good. If it is less than the 70% or 7, so by thumb's rule, so it is not giving the best model. So now the R square that R square can be visualized when you have the georeference. So that is the visualization of your R square. And here, for each and every village or each and every space, we are calculating the R square. Then where the R square is very high, that is in the red color. Where the R square is very poor, very low, that is in the green color. So that can be visualized. Your regression analysis value can be visualized in the map. Similarly, you have the beta coefficient x1 and the beta coefficient of the x2, beta coefficient of the x3. So beta coefficient of the x5 like this. So all these things you can do it. So this is a high advanced spatial data analysis. And this is a type of the some regression, spatial regression analysis. Now I will come to the other part in the next PPT. I will come to for the related to the R code. Now this is a time is included in the spatial analysis. In the spatial analysis, what you need attribute. Attribute is nothing but your outcomes, and then space. Space is your georeference. Now I have included the time. So we have the three component. One is the space, and one is the attribute. That is a simple spatial analysis. And if you include the time, we have the three component. Then is the spatial temporal analysis. So attribute is nothing but your breast cancers of the woman in the Assam. That is what we call it the what. What is happened in terms of the regression, in terms of the health of cancer among the women. Where is that is the your space. That is 26.72 degree north and 94.35 degree east. When? That is in the 2025. Again, you can ask when previous 2024 and 2023, 2022, 2021, 2020, the last 5 years, you want to see the trend. That is a spatial temporal analysis. So this is a one kind of the spatial temporal analysis. Mapping after the analysis. See in the 2011, see the figure 2.A, the first figure you see, nothing is there in the Sikkim, all are dull color. But here you see 2019 in the last button, last corner, left, right side. So Sikkim all 4 districts, and now the 3 districts are red color. That means all the cesareans are conducted, most of the delivery in the Sikkim. So the changes are there. So that is the spatial temporary. This can be done through the local indicator spatial autocorrelation. That is the LISA technique. That paper also published. Okay. Now health implication is there. Now some challenges are there in the spatial, that incomplete of your georeference or address is somewhere written in the text and it is not properly written. Some mistakes are there. So many things are there. And then the ethical issues are there when you are related to the persons and you are doing the analysis with the dead person data. Then some ethical issue also there. And nowadays we can integrate with the machine learning. So machine learning random forest. I think Dr. Ayappan Jiran is already explaining you about the logistic regressions and about the random forest, about the support vector analysis, or the graph of the Burato for the variable selection. And all this can be included in the spatial data. That is the advance. Nowadays, we are doing the advanced spatial analysis along with the machine learning. So you can do it, means that is integration. And the real-time surveillance, I am putting regarding the disease, you can do it for the economic You can do for the business also. And the same thing, mobile health or mobile and the climate change link also, you can include all the spatial analysis. Now I am coming to that another slides. That slide is related to what? Techniques of the now slide is visible, Madam Dr. Aruna. Slide is visible. Dr. Aruna, slide is visible. Is this slide is visible? Hello.
Yes, sir, it is, sir.
Okay, okay. So you give me this answer because I'm changing one slide to slide. And then after that, I am going to change to the another slide, that is R Studio. Okay. Now this slide is related to the R. Okay. The previous slide is related to the concept of the spatial. Okay. Now, spatial, for the spatial data analysis, what we need, the spatial data, the shape file data we need, along with your data. Okay. Now, some of the data are available in the free domain. Okay. So the GADM, this is the one of the website. The earlier it was the version 4, 3.6 and 3.8. Now 4.1 is there. Now from the 2026 January, another version is going to be start. Then in this 4.1 version, we are available in the free, we are available up to the sub-district level. Country level, India country boundary, then state level, then district level, then sub-district level, not in the village level. So maybe in the next version 5 series, so the village level may be available. Another one is the data meet. From the data meet also we can download it. We can use the free spatial data. The third one is Diva GIS. So these three, what I explain is a free spatial data available in the website. Okay. So I already said that one is the country level, one is the state level, one is the district level, one is the sub-district, one is the block and the village. But right now in this above website, we will get up to the 4. 4 means serial number 1, serial number 2, serial number 3, serial number 4. I am talking about the country, state, district, and the sub-district, not in the block and not in the village level. It's not available. If it is available, it's okay. But here in that website, it's not available. Okay. Once the data is a download, then we can draw it the state, the level number. This is state is the level number 1. State is the level number 1. Okay, so this level is very important when we are coming to the R code. Level 0, level 1, level 2, level 3. Okay. So this is the level 1, the state. So after downloading, that is the extracting. How to extract the data, how to download the data. It's a part of the data management of the spatial. This can be done using the R, or this can be done using the GIS. This can be done using the Stata, and another one is a Diva GIS. Diva GIS is not a good software. It is some limitations are there. The advanced is GIS, R, and Stata for the data management. Then we can plot our geo reference. The red colors are the 1 point, and their geo reference is captured. It is put it in the Excel sheet. and that Excel sheet data is merged in the shape file of India and then plotted in the India map, the georeference. And that this is the point data, and this is for the polygon data. In the polygon data, after visualization, then we can give it the range in terms of their value. We have the classifications, 5 division of classification on the value of the anemia. Then we have divided into the 5 category. Then we are looking where is the high anemia. So Jharkhand and then Haryana is showing the red colors. So this can be done using the R and all other software. So point and polygon, we can do it. Now I am coming to that R code. Now, before coming to the R code, let me come to the first and the Google's here. See, GDAM. So this is a website for the GADM. Click here, then we can click the India. And then we can click the save file. Then after that, we can download it. After that, we can download it. And download is coming here in the download folder here. In the top corner, here I am putting in the mouse, this one. So this map is the shape file data is downloaded. In this shape file data, 0. So 11.0, this is the country, and this is the level 1, and this is state. Level 2, this is the district. Level 3, this is the what? Sub-district. Okay. So similarly, when you go to the another website, when you go for the another website, just 1 second. Diba GIS, Diba GIS, save fund downloading. So here also, now you are going to this Diba, then Diba GIS, then click on the here, then select the India. Then after that, you start your download. Then you start the download. Before this, you have to select the administrative area. There are so many data are available, water and the road, then elevation, all these things. But we need the administrative area. Click on the administrative area, and then you start the download. Then download. Then it will come to your folder in the download folder and save it in your proper folder. Okay. Now this is where the public domain save file are available. Now I am coming to the point of this thing. through the data we can close this one and this one close and this one close. Now I am coming to here, then stop sharing. Now I will share the code. Now this R code, R Studio is visible. This R code is visible. R Studio screen is visible. Please say something.
Yes, sir, it's visible.
Okay. Now I am coming to the code. Okay. So this time I will explain you only the some basic thing. The advanced thing maybe sometime, maybe in the another day I will explain you the advanced one. Okay. Now first what we are going to do is we are going to import the georeference of the X and the Y of the few Assam, few villages in Assam. Okay. Where is the that data? I kept it in the my folder. Okay. So session here and here, it will go to the folder. Now I have already done in the code set working directory. Now I increase the my size, control and plus, control and plus. Okay. So I'm here in the line number 7. So this is my folder. This line number 7 is my folder. So in this folder, my data is here. This is my data in the Excel. So now Excel is importing using the library, Rio, and this. Now I am just looking for the data. Now this is 10 data, 10 georeference. One is for the Tezpur, Golaghat, Nawang, Gopur, Silchar, Hailakandi, Nalbari, Barbeta, Dipu, and Dubri. Okay, 5 georeference is here. So that georeference is in the data set in the Excel sheet. Now this data is importing in the R Studio, in the R platform. Okay. So this data is, I check it, all the data, 10 data are coming. Now it is converted data frame. This is the data frame, the function. So this data frame is the function making the data frame. So these two data, one is the X and the one is Y. So this X is longitude, another Y, another one, that is the Y, that is the latitude. So this is put it in the form of the one vector data in the name of coordinate. That is the line number 17. This is the coordinate. So that coordinate, again, we want to see it is coming or not. Now it is coming in the form of LON, longitude, LAT. LON and the LAT, these two words is understand by the code coming in the down. Okay, so this is there are code R language, these two, and this one is my data, and this one is another my Y data, the second data. So this is the longitude is the axis and the latitude is the y axis, x and the y. Now coming to this library Geoda, this is a very beautiful library. It is updated from the previous. In the previous, we are not able to download directly. Now here is we can download it through the Geoda. Now this downloading, what I am downloading, the country, that is a country. Country is defined by the India. This India is only the code is there in the GATM in that website. So India, they have written in the shortcut IND in the capital form. Now the 11, what 11 I am downloading? This 11.2. In the PPT, what I mentioned, the 11.0, 11.1, 11.2, 11.3, 11.4, and 11.5. But right now in the public domain, we have 11.0, 11.1, 11.2, and 11.3. 11.3 is the sub-district. 11.2 is the district. And 11.1 is the state. 11.0 is the India country. So what I am downloading? I am downloading what? The level 2, the whole India district. The all India districts, the whole districts of India I am downloading. So I started downloading here. So it will take some time. It's depend upon the your speeds of the your internet. Okay. So now it is downloading. Then after downloaded, then I am going to subset the districts of the Nawang here. And this is the name of the variable given in the PDF file, that in the database that you can get in the Excel file. When you go to the save file, then open it in the Excel, then you will get the name of the variables of the districts in the variable name of the name underscore 2. If the name is name underscore 1, that is the name of the state. Name underscore 2, that is the district. Name underscore 3, that is the name of the sub-district. Name underscore 1, that is the state. So like that, the level 2 and the name underscore 2, this is very important thing. Now Nawang is selected, and then again it is converted in the form of the ST function for reading in the Excel. Now plotting this object, I am plotting this object. This object is nothing but the Nawang object. So Nawang is coming here. Nawang districts is coming here. So here is all the variables in that data. All the variables available in the database DBF file is there. So 1, 2, 3. So nine variables are there. All the 9 variables are coming here. Now I don't want this thing. I want only the one map. One map. So another example is we can use the library leaflet that is in the line number 47. So using the library line number 47, and then we are calling it in the form of the tile. These are the language. From here to here, these are the language of the R code for the mapping. So Nawang is the input here in the data set. Nawang is the data set, and then this is the beautification, and this also beautification, and this is the boundary. What is the thickness of the boundary side? 5 is almost somewhere middle. Then if you are giving 3, it will be smaller, small line. And then if you are giving the 20, 25, then it's thicker and thicker. Now I have run this code from line number 50 to line number 59. Then it is captured from here. So this so this map is coming here. So Nagong is again, it is captured. So this Nagong district, so it is already geocoded by the remote sensing people, and it is available in the GADM website. So from there, we are using this one. We are using directly through the website. Now, this district, you want to save it and keep in your folder, that we can do it. That is the data extraction. Now, this data is you are visible. This data you can extract and you can keep in your folder, in your desktop, in your computer, in your laptop for your purpose. Okay. Now, next is, now this is the district I capture. Now I want to extract, I want to see the state of Assam. Now I have run the command. For what command? I run this whole states of India. Whole state of India, that is in the level 1. And then in the level 1, there are so many states are there. So in that state, I have given here Assam. So Assam state will give you that Assam. Now for the mapping purpose, I have converted using the AST function. Now our object is, this is my object. So this object is, I am just plotting here. So Assam is coming here. So this Assam is whatever this map. In this map, what is coming? All the variables available in the available in the in that database DBS file. The 9 variables are available. All the 9 variables are coming here in the Assam. That is a polygon of the Assam. Now I want to see this in the one figure. Similarly in the that Nawang. Similarly in that. So I am just doing this thing. Same command. The color is changed here. The color is changed here in the line number 83. The previous code, it was the red color. Now it is black color. So now instead of this 5, I am just putting the 15. The size of the boundaries of the Assam, it will be increased. It will be increased. Right. So now I am putting the 5. 5 is, for me, is okay. That is why I am putting the 5. So I am coming back to the previous code. Okay. So now this is Assam. So now we have Assam and Nawang, 2 districts, one district and one state. Now I want to put it in the one map. That is nothing but the concept of layering. Now we have 2 layers. The first layer, that is the Nawang. The second layer, that is the Assam. So we want to keep it in the one map, the layering of the 2 map. Okay. And now we have the two data we have from the website. We have extracted, we have taken the Assam and the Nawang. So this is the Assam and this is the Nawang. Now these 2 map, Nawang and Assam, I want to use for the future purpose in the others. So I want to take it and save in my computer. Then you have to give your path. You have to give your path where you want to keep it, where you want to save. That is why I have written here in the line number 89, save the save file. Save the save file. I am just increase one more. So save the save file. Then after that, this is the command for saving of the district name, Nawang. and it will be saved in that folder. Similarly, for the Assam also, it can be saved in that folder. In the one folder, if you are giving the same path, both the save file, Nagaon district and Assam state will be saving in the one path. If you want to give another different, then for the another different, then for the district you save it here. For the state you can save it here. So different part. Okay, so you can do it in your own style, whatever you want. You want to keep together, then this one is okay. You want to keep in the separate, then you have to give the different two parts for the saving the data. Now what I am saying is that I have already the coordinate. The previous we have the coordinate of the what? We have the coordinate of the 10 places in Assam. We have the 10 places georeference. So that georeference I want to plot in this map. So now here the first one is what? The first one is adding the Nagaon boundary. The second one is adding the what? Georeference. So this is the latitude and this is the longitude. Now from here to here, this is the part of the Nagaon. And then this is the adding of the next layer. Here also same thing. This is the adding of the next layer. And here is the coordinate. So in this coordinate, we are adding another layer using this file, and then another layer using this file. So now we are running this code. Now we have the this data and this map. So all the 10 reference points, georeference points are coming, and then your district also coming. But the Assam is not coming because Assam is not included here in this code. So now here in the next, I am putting the Assam. That means from here to here is the Nagaon, and from here to here is the point red in the red color, and then from here to here is heading of the Assam. Now I am running the code here. Now it is coming here. So now so it is here like this. Okay. Now you can put your location map. Suppose Dispur. You can put your location map of the Dispur. Dispur. It is a Dispur. Okay. Now Assam. Now I am adding the one point here. This point here, the longitude latitude of this. Longitude latitude of the Dispur. I have collected from the Google map. Okay, from the Googles. So this point longitude and latitude is collected and putting here. Then the
So may I make an announcement? I can hear some background noises. I request the participants to
Now
Please.
it is coming.
Now it's fine, sir.
So now, so this is the map for the. Now this is the. So this is new one location map is putting here. Okay, so this is the location map of the your Dispur. Okay, the first what we try it, we are trying to for the district map of the Nawang. Then after that we try for the how to plot the 10 georeference point in the Assam. Then how to extract the Assam district and how to layer the districts of Assam and the districts two layering adding in the one code. So that we have done this thing. So here, so different color and a different districts you can take it. So instead of Nagang, you can take it this Nalbari side, you can take it, or you can take it in the Hailakandi district, you can extract, and then you can do it the location map also. So each and every points of the headquarters of the districts, you can put it in the location after putting their geo reference. So this is the one of the example of the this from the website how you can do it. Okay. Now I am coming to the another one. This code I am sending you, okay, and the PPT also I am sending you. Now I am just opening the another one small software. It is also very useful one. So now this is visible, this one. This one is visible. This new one. This screen is visible. Is this screen is
Yes,
visible?
yes, sir. It's visible. It's visible.
Because I have changed another slide. Okay.
This screen shows connect to data source, drop files here, input file.
Fine,
Yes.
fine.
Yes.
Okay. So now when you open your Geoda, when you open your Geoda, this will come. Automatically this will come. Okay. Now I am opening my save file here. This is free software. Here you can do the simple mapping and a simple polygon map and point map, and then a little bit advanced is the local indicator spatial autocorrelation and two regression analysis. You can do it here. Now I am going to show you regarding the regression analysis part. Okay. First, I have to import my save file. So here there are different types of the files are here. Different types of files here. I am going to use this save file, and then another file is the Excel file. Because in the Excel file, my data is, I kept my data in the Excel file. So now first I import this Excel file. And where is my Excel file? I am going to here and going to the my data file. That is in the spatial file. That is a part of the geoda, and that is the district map. Then district map boundary number 2. So this is the shape file. Okay. So this shape file is available in the National Family Health Survey, NFSS. In the NFSS, we have collected a georeference. So this is 707 district shape file, and it's available in the public domain under the NFSS 5 IAPS. Okay. Now, this is the one layer. The second layer, second layer is the state one. So I am putting, or I am importing another one layer. So the plus symbol, click, then here save file, and then coming to the state. This is the state file. So this state file also coming here. Okay, so now you can play all these things here. You can interchange all this, and color also you can change all these things. So here also many things you can work it for the spatial data analysis. Okay, now another thing is, see in the mapping also quantile map, how many quantile you want to divide, and percentile map, click here, then standard deviation map. So, and then natural brick. So when you click here, then you have to pick up the one variables. Then on the basis of the your variable, then your map will come, visualization of the polygon map will come. Now I am not coming in that part. I am coming in the regression area. Okay, in the regression area. Now we have these two data file of the spatial map, spatial data. Now I am going to import what? Excel file. My Excel file, I am going to import my Excel file. Where is my Excel file? Just 1 second. Yes. So let me start from the beginning again. I just practice because my internet is not available. I connected from the mobile. So they have come here for the internet checking. Now, see here, the first one. Okay, the first one is importing of the save file. Importing of the save file. Importing of the save file. See, to close this one. Okay. Again, it's going. Geoda. Geoda. Now this one is visible. I
Yes,
start
sir,
again.
it's visible.
Okay.
Zoom screen is visible.
ठीक है. Now Geoda is coming here. Now first let us import the save file. Click here. Now I am importing district save file here. So district is coming here. Then now I import another state file also here, and then that is in the state folder here. Okay, so this I all this on, you can play all these things, you can make it the layer one by. Now I'm coming to the weight, how to create the weight. So before creating the weight, you have to merge the data set here. What is the data set? My data set is in the Excel file. In the Excel file, that is in the CBSV file. So that is, I just pick up this Excel, then click OK here. All the files are coming here.
Please, excuse me, sir, excuse me. Sir, your screen is not visible.
It's not visible.
Yes, sir.
Okay. Now click here. It's visible.
Yes, sir.
Yes, it's
visible.
visible.
Okay. So now coming to this table and merge, then click here and then merging the file of the CSV. Then this is the data 105 Excel sheet, all the district value of the smoke Caesarean sections are keeping here, and select all the variables and keeping here, keeping this side, and that is included in the save file. Now it is okay. So in the save file, that Excel sheet are merged. Both the files are merged together. Now coming to this space. For the mapping, you can do here, all the mappings, mappings are here, polygon maps are here. Now I'm coming to the here space, and univariate Moran I. Before univariate Moran I, we have to create the one weight. So weight manager, and then after the weight manager, create, click on create, then add the this, and then now create, then I am putting the name of this. Last time I prepared the weight, so similarly I prepare the weight and save it and okay. Then now this create is finished. Then coming to the space, then this, now I am going to take the Caesarean sections, that variables in the Excel file. That Excel file I have entered in the Excel file. That Excel file is merged in the shape of the whole 707 districts. Then click OK. Then I want to see the significant also and the Moran also. Then click OK. And then this green color is the significant map, and this red color is the red color, and the blue colors is the the Lisa indicator map. And then this is the Moran. So Moran is showing that Moran indicator is showing that the correlation, the relation between the value and the space is 0.330. The 0.330. That means your correlation value, autocorrelation value is 0.3. That means you have some correlation is there. So this is mostly somewhere in the first quadrant and little bit in the some values are somewhere here. Mostly the datas are in the first quadrant, right? So this is the value of the Moran I. Moran I is the global. There is some spatial relation is there. That is the idea of the correlation. Now we are trying to find out what the local indicator spatial autocorrelation. So high is high boundary. The high district is neighborhood of the high district. Okay, so that is the high. One is high, another left side also high. That is a high. That is our hotspot area. And low means our cool area. The color you can change it when you click it and change it in the green color. It will be green color. So by default, red color is the high, and cool is the blue color, low. Other one is low is surrounded by the high village or high district, or the high district is surrounded by the low district. So these two are not important. The total number of district is 707 districts. Now high cluster is 44 districts and the low cluster is 119 districts. And then the statistically not significant is 513. When you add all this value, then you will get a 707 district. Then from this map, from this visualization, you can understand, oh, the survival Caesarean section is somewhere here in the Madhya Pradesh area and the West Bengal area and some Odisha area and somewhere in the Assam area, and then somewhere in the Darjeeling site area and some part of the West Bengal. So you can interpret all these things from this. But the Jammu Kashmir, by default, the Jammu Kashmir is
Sir,
not.
sorry to disturb you. It's a very interesting topic, but the clock is ticking away.
Hello.
Yes, sir. The topic-
Time is 2 o'clock, and I am going to finish right now.
Yes.
Another
Okay.
2 minutes I will take. Regression, I am coming. Okay. So now, when you want to put the Jammu Kashmir boundary here, then in the left side you see Jammu Kashmir boundary is here, right? So you have to give the layer here, then Jammu Kashmir, that boundary, Akashi, Chin, and then the Pakistan occupied Kashmir, that will be putting in the second layer. That will be your complete India map as per the BJP government. Okay, now coming to this, now this is the Lisa, and here is your significant value, significant map, and this significant map is only your for purpose. For the research purpose is that hotspot one. Now I close this one. Coming to the regression analysis, this is the last part of this session. Now when you click the regression, then you will get this thing. Okay. Now what is the dependent variable? Dependent variable is the Caesarean section, the proportion of the Caesarean section, the prevalence of the Caesarean section. What is your covariate? Covariate is the literacy of the women per district. Now we are discussing about the 707 districts. Okay. Then when you click the weight is already I have created in the name of the weight in that file. So automatically it's pick up. Now you have the spatial lag and the spatial error two model in this software. And this classical is our previous classical, the traditional statistics. And here spatial and spatial error. How to choose the spatial lag and how to choose the spatial error? The one diagram is there. That diagram is already in the PPT. I will give you in the PPT that diagram. You have to decide it. Now I click in the spatial lag model and then I run it, click, then within the 1 second all the analysis result will come, and this analysis you have to interpret it. And then if you want, this is the error model. Now I am just picking up the log model, spatial error model, then run it, then this output will come. So from this output you have to interpret the interpretation part. Okay, so this is the available in this software about the regressions. Two regressions are available, and then another one is for the traditional regression. So three available. One is the classical, and two is the advanced spatial analysis. Last time what I told is regarding the Bayesian spatial regression, hierarchical spatial regression, geographical regression. That are not available in this software. That are in the R, somewhere in the Stata, somewhere in the WGDR, that particular package. So this must I cover it today. The advanced we can do it in somewhere in the other one session. And spatial is very big area, and almost it will take hardly 20-25 hours for the whole session. And there are so many calculations and so many mathematical formulas are there, and I pick up only the few important things and then I present it for you. Thank you, madam.
Thank you, sir.
And all this PPT I am sharing you, and the data file you will
Yes.
get. Okay.
Sure, so I'll forward it to our participants. So thank you so much. The session was very enriching, and I hope our participants have taken the session, taken information about the session, ideas from the session, and they would surely implement it. And we do plan to organize such sessions in the future as well. So looking forward for your collaboration in the future, sir. This was the second session with you. We had a session in the second day as well. So looking forward to work with you in the research area. So now, so a small certificate of gratitude to you, sir.
Okay. Thank you. Thank you.
Thank you so much, sir. So as we move ahead to the last and the most important section, session, that is a valedictory session of this 5-day workshop, I hand over the session to Ms. Vaishali Pathak to carry forward.
So let me leave.
Thank you, ma'am. I hope I'm audible. So very good evening to everyone present here, respected resource persons, esteemed guests, participants, and all of you who have joined this online Zoom meeting. So I'm Vaishali Pathak, and I welcome you all to the valedictory session of the 5-day online workshop on data analysis in academic research using R. So according to the agenda, we had a few members from our university as well as AIU to address, who were supposed to address in this valedictory session. But due to some urgent meeting in our university as well, they couldn't join. But today we have with us our Dean of Research and Development, Professor Ramaranjan Bhattacharjee, sir. And I'd like to request sir to give, yes, welcome, sir. So I'd like to request Sir to address our participants in this valedictory session. Sir, you need to unmute yourself.
Yeah, so thanks a lot, Vaishali and Aruna, for giving the opportunity, and to the management also. And uh, I guess it was quite nice of a program. And I was trying to tell Dr. Singh not to log out because he was asking about logging out. So he might have stayed online. But anyway, I think he has logged out. So it gives me immense pleasure to address this valedictory session of the 5-day online workshop on data analysis for academic research with R, organized by RGU in association with AIU AADC. So over these few days, I hope the participants have embarked on a meaningful journey that combine theory and practice, equipping participants with essential analytical skills for academic excellence and research advancements. So this workshop has provided, and I guess, an enriching platform for scholars, faculty members, and research enthusiasts from different parts of the country to explore the power of R programming in handling, analyzing, and visualization of data. So, for the fundamentals of R, syntax, and data structures to advanced techniques such as statistical modeling, hypothesis testing, and data visualization, every session has been a step forward, becoming more confident and competent researcher. So, a heartfelt gratitude to the organizing committee, whose meticulous planning, technical coordination, and constant support ensured the smooth conduct of this online program. So, to all the participants, your enthusiasm, active participation, and curiosity have made this workshop truly interactive and rewarding. So I am confident that the skills acquired during these 5 days will empower you and approach your research data with a renewed confidence and creativity. So let this not be an end, but the beginning of your continued engagement with data-driven academic research. So again, thank you all once again for being a part of this journey, and wishing everyone continued success in your academic and professional endeavors. All the best to all of you. Thank you very much.
Thank you. Thank you so much, sir, for inspiring words. So as we come to the end of this valedictory session, now I'd like to request our convener, Dr. Aruna Devroy ma'am, to please come forward and present the rapporteur's report of this workshop, as well as give the vote of thanks.
Thank you, Vaishali. Good evening, everyone. So I would like to present the reporter's report, a brief summary about the 5-day workshop on R. Well, it was an enriching learning experience for all, which I can, which I can share, which I can see the experience that I can take up from the feedback received from the participants, the chat box after each session. Well, starting with the summary of day 1, we had the inaugural session where we had our registrar administration, Professor Diganta Munshi. We had Professor George AP, the coordinator of AIU AADCRGU, and AIU official, Ms. Ranjana Parihar. And these resource persons, they stressed on how important such programs are in focusing the current day needs of research. So a total of 86 registrations were done for this program, which includes research scholars and faculty members. So day 1 session started with Dr. Amber Datta from MIT University on the topic Basics of R and R Studio. Sir spoke on the basics of R and R Studio. He gave a lucid explanation which was helpful for the beginners from multiple disciplines. Session 2 of day 1 was taken up by Dr. Bikash Borwa of Royal Global University He spoke on the technicalities of managing data and showed with examples how to add data, manage it, and its usefulness in research. Day 2 first session was taken up by Dr. Jiten Kumar Singh sir from ICMR, New Delhi. And the topic was on advanced data visualization, where sir explained us the use of sophisticated techniques, tools, and methods to represent complex data sets in visually intuitive ways, making the session not only interesting but also an enriching learning experience. Next, we have Dr. Himadri Burman from Dibrugarh University, and sir's topic was descriptive statistics and data summaries. Sir delivered the session on descriptive statistics, where he explained concepts from basic to advanced level so that it can be helpful in the research work of the participants. Day 3 first session was taken up by Dr. Arpita Basar from Guwahati University, and Madam delivered her session on the topic hypothesis testing with R. She started from the very basics of hypothesis testing to advanced level using R's software. It was a wonderful session, keeping all the participants glued to the screen. Second session on day 3 was taken up by Dr. Vivek Verma from Assam University. Sir spoke on the simple and multiple linear regression, where he explained the concepts with multiple data sets to explain the simple and the multiple linear regression concept. Day 4 was taken up by Dr. Jiran Mitai from Maharaja Agrasen College, New Delhi. And sir's topic was machine learning and predictive modeling using R. The session involved learning about machine learning and predictive modeling, which was a very enriching session intellectually. The participants learned the technical skills, and in a very dynamic way, they will be able to apply the techniques as it was explained in a very simple way. Next session of day 4 was taken up by Professor Ishankur Saikia from Guwahati University. The topic which Sir spoke on was time series analysis and forecasting. Sir's session was very interactive, and he customized the session as per the needs of the participants. He cleared the queries of the participants and curated his session to fit the need of the present day research. Day 5, it is today, the first session was taken up by Dr. Rashad PP from Institute of Analytics, ISDC, Kochi. Sir's topic was hierarchical linear modeling, and Sir's session was an elaborate session where concepts were explained from basic to advanced level, thereby helping the participants to learn the concept of HLM in depth. Next and the last session that was over just now was taken up by Dr. Jiten Kumar Singh from ICMR, New Delhi. And Sir's session was on spatial analysis using R. Sir helped us to understand the concept of spatial analysis, where he showed us the process of examining locations, attributes, and relationships of features in spatial data through various analytical and statistical techniques, which helps to uncover pattern, trends, and association in geographic or spatially referenced data. And it's pretty much relevant for the upcoming researchers as well. So I thank all our research, scholars, our participants, our resource persons, and the dignitaries who were a part of this 5-day workshop. Now, a heartfelt gratitude to our guest of the day, Professor Ramaranjan Bhattacharjee, sir, who is our Dean R&D. Sir made his time to join us in this valedictory session. Thank you so much, sir. Our next workshop will be organized in the month of December 2025. So I request all the participants to join us during all our upcoming programs. The information about the program will be available in our website, that is Royal Global University's website, Association of Indian Universities website, and all the other social media handles of Royal Global University. For all the information about the upcoming workshops, you can also be there in the current WhatsApp group that we have formed. Information will also be shared there. For this program that we ended today, an email will be sent to you asking your feedback about the program, and which has to be submitted by 18th, that is tomorrow, 6 p.m. And also the certificates will be attached there in the email. In case of any queries, please feel free to connect to us through the email ID that was given there in the brochure. If there is any corrections required in the certificates, please respond to us in the email itself. Our special thanks to Association of Indian Universities and its officials like Ranjana Parihar Madam, who believed in us and allowed us to organize the program. As we conclude today, let us carry forward the knowledge and insights gained here into our respective research and teaching practices. The use of R in data analysis not only enhances the credibility and reproducibility of our research, but also opens new possibilities for innovation, evidence-based decision-making, and interdisciplinary collaboration. Thanking all of you once again. Have a great evening. Thank you, everyone.